generalized group, right? So,
Yes,
and generally
because you want
speaking,
to.
all Globers mock and ridicule you for saying the word ether, and they repeat their mantra, which is the ether was disproven 100 years ago. They just say that over and over and over.
Yes, and then when you speak to the individuals, you'll find out that nothing that you say is actually even true. Like, yeah,
So you disagree with
you
all the
can.
Globers that say the ether was disproven?
Either in that form it was disproven. Yes.
See? So, and actually they're sitting here saying it looks like that form actually is much more viable than relativity on the quantum scale, and now they're trying to figure it out because then they'd have to go back to Michelson-Morley, which if the Earth is moving, then there cannot be an ether like that. So they don't know what to do.
Yeah. See, but I don't actually disagree. Like I said, I found out some. I used the university library and I found articles about the ether. I don't disagree with any of them because they are not arguing for that either. Or
So,
if they
okay,
are,
now
you are feel free to make that argument, I guess.
do you agree that in physics, when we discover new evidence, that we then have to try to narrow it down to viable options and work from there?
Sure, of course.
Okay. So can you think of a viable option based on everything we were just discussing? What would be a viable option to explain things?
Viable option, like that's a viable option to explain things. That's way too vague. It's a malformed question. Like you need to specify it more for it to
I
be an
just said
empirical
specific to
question.
what we've been discussing. I just said that.
Well, we're talking about, roughly speaking, the conversation is currently either has been considered, like there are new versions of the ether theory going about that are being considered. Yeah, that's an option. Yeah, sure. I guess that's the best I can do with this.
Here's the more specific answer. If new evidence always boils it down to a new limited option list of viability, if we're looking at what all the evidence is showing us on the quantum scale and vacuum energy, zero point energy, all this stuff, where like there's this all-encompassing stuff. It appears like everything is different versions of this same all-embracing stuff, and all the forces are unified. It seems like the most like that's the most consistent with the evidence. And then we look back at relativity, or we look back at Michelson-Morley, and we're like, oh well, there can't be a substantive ether like that. Even though all the evidence is showing us that, that can't be the option because if we look at Michelson-Morley, if the Earth is orbiting through an ether like that, then we would have seen the fringe shift. So the now objectively, a viable option is that there is a substantive ether, which explains all of these issues in quantum, and that when we go back to Michelson-Morley, we just have the Earth be stationary. Then all of a sudden, Michelson-Morley works perfectly, and we can explain all of the quantum phenomena. So that is a viable option, right?
I don't. I don't think it is because we actually know that the Earth moves, and I don't think there's any good reason to push us in that direction either. So, for two good reasons, that's not a viable option.
First of
How,
all, you just saying there's no good reason is in no way a rebuttal. I just described the very good reason, which is to actually explain all the discrepancies in quantum that we have right now. That's a pretty good reason
oh
to
my God.
explain all the question marks in physics on the quantum scale. Okay.
Shits it. You're so funny, shits it.
And how do we know the Earth is moving? When did that get proven?
Oh, ages ago, I guess. Most recently.
Yes, I guess.
No. Sorry.
Fuzzy,
yes.
you have a very loud background noise. Just
Yes.
so you know. Try keep muted if you're not speaking, please.
I use the word I guess because there are very well known facts about reality that the intellectual history of actually when did they even get proven is like really difficult. Like, when did we discover fire? Everyone knows we did that. When did that happen? Who the hell knows?
Well,
It's
actually,
the
the
same
current
for when how do we know that the Earth is a globe and spins? Well, who the fuck knows, man? It's such a long time ago, and you guys should be
Up
on the
until
edge.
Einstein, up until I guess what the 40s or some odd, said that there's no way to prove or optically show that the Earth is moving.
Yes, optically, and you know the typical answer already, which I'm not sure why you didn't accept the answer because it's a good answer. He was talking about certain types of experiments and not the all of human understanding. So
Actually, he
if we
says
consider all of human understanding, yes, we
no.
do have ways of knowing
He actually didn't
that
say
the Earth
just
moves.
optical. He said terrestrial experiment.
Okay, which quote is that exactly?
Yeah. So he said that
Because
there's
he did say optical, so which one is correct? The guy who just said the quote, or are you?
these are different quotes. They both are
Okay,
correct.
okay, yes, okay. So can
Okay.
you show me the other quote?
Yeah,
I
sure.
haven't seen that one.
Okay. So anyway, there's a quote that says um, optical experiment, and then there's a quote that says any terrestrial experiment.
Hmm. So in the case of both of those quotes, is Einstein still actually talking about these certain types of like Michelson-Morley type experiments?
No, he says
Earth
any
movement.
terrestrial experiment.
Yes, I know what the words are. I was asking about the context, and you're now
But the
deviating
reason
from
I'm
the
even
question.
bringing it up, the reason I'm bringing it up is because you said that it's been well known for a long time, and I'm just here to tell you that at least since Einstein said it wasn't well known, you can't show it or prove it to be actually moving. So I'm not sure what you're talking
I
about.
actually I can, because like I already said, if I'm correct that Einstein is talking about these certain very limited types of experiments that it cannot be shown by them, then that leaves a whole ballroom where I can still show. And you
Please, please show
at
us.
least
Please show us the proof of Earth turning.
No, wait,
oh
wait,
yeah,
wait. No, what he's
Bob did
trying
it,
to
yeah.
they always
I know.
they always bastardize what Einstein say. It says and misrepresents it as if he's talking about just one specific thing when he actually says terrestrial experiments. Terrestrial means on the earth. Okay?
Yes,
So
but we are not talking about that quote.
it says in Relativity by Einstein 1916. It's called Relativity, the Special and General Theory, his summary of the theories. He says,
Yes.
second class of facts to which we have alluded has reference to the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments.
Okay, cool.
We have already remarked in section 5 that all attempts of this nature have led to a negative result.
So yes, I don't think that's the quote that was being referenced to earlier. So that's a different quote. If you want to talk about a different quote, we're free
It
to
definitely
feel free to
was.
move the conversation to that direction. But let's actually focus on the first original quote that's under the discussion here.
They just want to avoid it. So the actual point that Fuzzy
No, but
brought the quote up to support was that relativity says that you can't prove the Earth is moving, and then he used the optical experiment quote, which is a certain quote. And in addition, he also said terrestrial. So as it pertains to the subject, they're both relevant, which is the point Fuzzy was making, which is that you can't prove the Earth is moving because that's contrary to what you claimed. And he specifically says terrestrial experiments, and he says all attempts of this nature. What nature? Terrestrial
yes.
experiments. So all terrestrial experiments.
Now you still haven't answered my question. I find it interesting that you still haven't answered
Wow,
my
you're just gonna
question.
avoid it.
The question that yes, you're gonna avoid it because it destroys your case. The question that you haven't answered is: I made the claim that he's talking about these Michelson-Morley type experiments in both of these contexts, and I was asking, is that what's being talked about in these contexts? You just completely ignored it, and you want to focus on the words because cherry picking on the words instead of the larger context, which is of course very important as to determining what's going on here. Of course, you don't want to look at the context because it destroys your case, man.
No, the contest here says very clearly that it's all terrestrial experiments. You guys have a script where you want to say it's
Ah,
just about Michelson-Morley or tests like that, but what it actually says is the second class of facts to which we have alluded has reference to the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments. We have
yes.
already remarked in section 5 that all attempts of this nature led to a negative result. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result for reasons now to be discussed.
To be clear, the only reason I'm bringing that up is because what year was that written? Because you said for a long time now we've known that the Earth is moving, which seems to be not correct. Is the reason I brought that up.
Yes, but it actually is correct. Furthermore, we can go full linguistics here. Which it seems to be of the opinion that the word "it" in it was hold on. All attempts of this nature. Which attempts is he talking about? Now, which it wants to claim that he's talking about the terrestrial, but in the what is actually mentioned before the word attempts, all attempts, we have already remarked in section 5 that all attempts of this nature. So it's referring back to what was mentioned in section 5. Now let's go back to section 5 and see what kind of attempts are being talked about there. I'm gonna make the claim proudly that they are talking about Michelson-Morley type experiments in section 5.
You've never even read the paper. They don't even mention Michelson.
Yes, but
they don't talk about Michelson-Morley in section. They don't talk about Michelson-Morley in section 5.
Cool story, bro.
Yeah. So the reason you're saying that is you were unfounded confidence here because you watched MC Toon or whatever, and he says, look right here. It says talks about Michelson-Morley, and it's actually later on. It's not before it in section 5. And of course, the context is very simple. If anyone has reading comprehension and is honest, it says that the second class of facts to which we have alluded has reference to the question whether or not the motion of Earth in space can be made perceptible in terrestrial experiments. So it's specific. That is the context. The context is the second class of facts that have alluded to the reference to the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments. That is what he's talking about when the next sentence says, we have already remarked in section 5 that all attempts of this nature, what nature is he talking about? Well, let's go to the sentence right before it, where he describes the nature that in the next sentence he says, all attempts of this nature.
Why is it so impossible to believe that he's talking about the experiments that he's talking about in the larger context? Like you're focusing again and again on the one specific word, terrestrial, instead of looking at the larger context. Like you have this very short quote, like maybe 2 sentences, and then you pretend that that's the context. Well, how about you look at the context of the bloody chapter, of the bloody paper? Did you even read it? No.
Yes.
No.
You've never read it.
And even if you did, you're cherry picking it, which makes it worse because then you know that you're being dishonest.
So basically what he's said is, even though he hasn't read it, and he lied and said that section 5 had Michelson-Morley in it. Okay, well,
if you just want to say that I lie, I'm gonna interrupt you and say you're being dishonest.
Okay.
There was no lie there.
Okay, you misspoke.
How about I interrupt, bro?
No, I didn't misspeak either.
You said that section 5 is talking about talking about Michelson-Morley. It's not.
You're completely misremembering or misrepresenting. So it's either you're mistaken or you're a liar. What I said quite clearly was I'm going to make the proud.
Okay, I guess I'll have to mute you. So, in section 5, it's not talking about Michelson-Morley. And I can go to section 5. What section 5 does, it gives you a bunch of like everyday examples on the Earth of motion. Ravens flying, trains moving, very basic observations on the Earth, the terrestrial Earth, right? Yeah, it's talking about observations of motion on the Earth. That's what section 5 is talking about. Then he says, and we now have the question, can the motion of the Earth through space be made perceptible in terrestrial experiments? Well, we've already remarked in section 5 that all attempts of this nature have led to a negative result. It's very clear what he's talking about, and he doesn't mention Michelson-Morley in section 5.
So I have to kind of object to your way of modding here. I kind of detest it because what did I do wrong for you to mute me? Because I wasn't over talking you. You were silent. So you kind of just mute me so that you can overtalk me.
That's not
kind
true.
of
I was in
thing.
the middle.
No.
You
You
would
were
chant.
silent. You were completely silent, sir. So I kind
No.
of detest you. And by that move, you, by the way, lose this conversation, because that shows that I destroy you so hard that you have to go back to your mute button like Nathan Oakley does. So I have now won this conversation because you admit that you cannot win this fairly. Thank you. That's such
That's
a
not-
classy move, man.
Listen,
Buddy, that's not what happened. And if I have to, I'll just
It is.
play it.
You were
through the mic.
silent, sir.
Now you're doing it again. Now you're doing it. So I could easily just play it, right? You interrupted me. I yielded the floor to you because you said you were interrupting because I said the word lie. So I just let you interrupt and I yielded. Then I went to start speaking again. You jumped back in to say I was being dishonest again by interrupting me. So then I had to mute you.
So you
On top of that-
accept that you were silent and then you muted me? Nice.
I wasn't silent. I was in the middle of a sentence.
Yes, you were.
No.
to be fair, okay, Larry, right. To be fair, he literally explained it out to you in very clear detail about what the context was in one sentence and the next. And
Oh,
you
yes.
completely disregarded that entirely.
Oh, no.
Oh yeah.
I gave
How,
good
how
reason.
you didn't articulate how he was incorrect in that interpretation of those two sentences after
Okay.
clarifying
So you
specifically
didn't
for
listen.
you.
So I can give it to you again. I gave it a ton of times. Like, he's focusing on a one word, terrestrial. I'm looking at the broader context. He's not. He's focusing, like, you can see it, like he's focusing on one word, terrestrial. That's one word interpretation. I'm doing larger. He's
he
not
actually-
willing to
he
go with
specific-
that. So I guess I don't know.
No, he very specifically went back to the sentence before that and now just went and told you about what actually was talked about in section 5 about the birds and all the other observations or whatever. He's then specifically and then said it again, and you're still ignoring it, and you're talking about how he mods and how you're ignoring what he's saying to not have to talk about it.
Yeah, I just went back and listened to exactly
Might
what
not
said
have-
happened.
Yeah, there's just no good reason to, like, go with his, like, if he can show me some good actual reason to accept his interpretation of this passage, but it's not, like, it's very vague as well, because, you know, pronouns, for example, this nature, that's very vague as to what that, like, that can refer to the previous sentence, it can refer to what's being talked about in the whole chapter. It's by far not clear what that refers to. He
No,
wants
this is-
to make a specific case as to what it refers to. It's up to him to make that case. For me, he doesn't present a promising case.
Okay, now
That's
this should be very telling to all the listeners that the globe proponent actually has to vehemently deny what Einstein's claim is. Because if the model's so true and the globe Earth heliocentric relativistic model is so accurate, you would never have to deny representing the actual claims of the person that brought it to you, right? But that's what they have to do, because it very clearly here says the second class of facts to which we have alluded has reference to the question whether or not motion of the Earth in space can be made perceptible in terrestrial experiments. We have already remarked in section 5 that all attempts of this nature led to a negative result. What's this nature? Well, you would go to the sentence right above it if you understand what context clues are, which is like 3rd grade. And it says whether or not the motion of the Earth can be made perceptible in terrestrial experiments. So tests of which nature? Terrestrial experiments attempting to detect the motion of the Earth. That's the nature of the test, since it literally explains the type of experiments the sentence before that.
So can I respond to that, since I let you talk instead of interrupting? Now, let's go through this passage. To the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiment, we have already remarked in section 5 that all attempts of this nature, what this nature is he talking about? He's talking about Michelson-Morley experiments. All attempts of this nature led to a negative result. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result. Which negative result, by the way? The negative Michelson-Morley result. So, of course, he's talking about Michael's. What other negative results are we talking about here? You have nothing to show for yourself, Witsit.
Okay, so now he's just baselessly
So,
claiming.
let me actually continue. See, it's actually quite
This is
interesting
bullshit,
that
bro.
Hold on, yeah, Laura, you gotta let him respond, and then also Fuzzy, you've got a background noise in your mic, Fuzzy. But go ahead, what's it?
Yeah, so it doesn't say Michelson-Morley. If you want to cite where it says it, I already know where Michelson-Morley is talked about in this paper. I already know. Okay, so what it says is all attempts, that's plural, and it says terrestrial experiments, plural. Okay, it wouldn't say all attempts, just talking about one attempt. Of course, it's saying specifically terrestrial experiments attempting to detect the motion of the Earth have all been negative. All attempts of this nature, of tests on the Earth trying to detect the motion of the Earth through space, have had a negative result. And he even references Section 5. And if you go up to Section 5, it's called the principle of relativity in the restricted sense. And it goes on to talk about different observations of motion on the Earth, right? Like imagine a raven flying through the air in such a manner that its motion as observed from the embankment is uniform and in a straight line. If we were to observe the flying raven from the moving railway carriage, okay, it gives specific examples of trying to test the ideas of motion on the Earth. Okay, that's the whole point.
I can address the plural part of that. See, there are several types of several of these Michelson-Morley types. There was this Gale as well. I forget the name.
Galilean.
Gale, yeah. So the plural is obviously referring to those types of experiments. The plural argument, like I never said that it's only the Michelson-Morley experiment. So the plural is a complete red herring. It has nothing to do with the issue on under discussion here.
What were Michelson and Gale and Michelson-Morley? What were they trying to do? Weren't they trying to prove Earth turn or Earth rotation movement?
Actually, I don't think so. They were trying to detect the ether. So it seems that you're not even familiar with the topic,
Right.
sir.
Okay, no, but they didn't do it because the Earth is moving, right? And that's what failed.
That's
Isn't that
your
the whole
interpretation, sure.
point of
But you're already incorrect as to what they were trying to do. So
no, obviously no. Well, movement, right?
they were trying to detect the ether. They didn't detect the ether because it doesn't exist.
All right, I'll just read it more. So, if the principle of relativity, this is Section 5. If the principle of relativity were not valid, we should therefore expect that the direction of motion of the Earth at any moment would enter the laws of nature, and also that physical systems and their behavior would be dependent on the orientation in space with respect to the ether. For owing to the alteration in direction of the velocity of rotation of the Earth in the course of a year, the Earth cannot be at rest relative to the hypothetical system K proper throughout the whole year. However, the most careful observations have never revealed such anisotropic properties in terrestrial physical space, a physical non-equivalence of different directions. This is a very powerful argument in favor of the principle of relativity.
Cool.
Do you understand what was just read?
Not too much, no.
Okay, what it's saying is it's a very powerful argument in favor of the principle of relativity because every attempt to detect the direction of velocity of rotation of the Earth in the course of a year has not been observed. Which means, since if we assume that it is in fact, of course, rotating with a velocity throughout the course of a year, then we would be able to detect it if the principle of relativity wasn't true. Which means since we don't detect it, but we know it happens, that's a strong argument for relativity. Do you understand?
Sure. There is an interesting problem with the argument here, though. What do you do with the fact that we can observe it?
Okay. Well, if you knew what he was saying, then you wouldn't say that because he's saying that you can't you can't use terrestrial experiment to detect the
Yes,
orbit
yes.
of the Earth. And if you think you can, then please provide one example of a terrestrial experiment that's able to detect the velocity of the Earth's orbit around the sun.
See, this is where you run into very, very deep trouble. I think that in epistemology, which deals with how we find out what the truth is, experiment actually trumps written word and quotes from random people, even if the random person happens to be Einstein. See, there's an experiment, I think some Bob named guy did it, which showed the rotation of the Earth, and experiment actually trumps all, even if they are from familiar authors like Einstein. So how about the fact that we actually do have experiments like that? So you're basically, I don't know, I have a trump card, because observations and experiments always trump statements.
Oh, but I observe it to be flat. Am I wrong?
Wait, dude. What? Come on, man. Okay, so you didn't understand. It isn't about axial rotation. It's about the velocity of rotation around the sun throughout the course of a year.
Game over.
Okay, so let's take this two parts. So would you accept that we can detect rotation then, though?
We do detect rotation, yeah.
Thank you. Do or do not those same devices, can they also be used to detect the motion of the Earth around the sun?
No.
Nope.
Yes, they can.
No,
Thank
they
you.
can't. And
Yes, they
Witsit
can.
just admitted something you can't. Weird.
Sorry?
I said Witsit just conceded something you can't, because you're always right.
He admitted something and I can't. Well, I'm not gonna admit to something that's wrong.
Well,
That's
Can you
fine.
please provide the?
If Witsit wants to admit to something that's wrong, that's his prerogative.
You're claiming that the same devices used to detect rotation, sidereal rotation, can also be used to detect the orbit. You asked me, can we use the same things to detect the orbit? And I said no. And you said that I was wrong. So feel free to list them, because you guys invoke Foucault's pendulum. That doesn't detect the orbit of the Earth. You guys invoke gyroscopes. That doesn't detect the orbit of the Earth. So I don't know exactly what you're alluding to, but please enlighten me.
Sorry, can you repeat that? I was answering to message on text chat.
Well, Laura, you just said that the Michelson-Morley and interferometry can pick up the motion of the Earth around the sun. Could you bring validation for that? Because they had to come up with the Lorentz contraction. There's all these other things that they had to they had to try to accommodate, and even to this day, there's no actual measurement of that. So, if you said there is, could you provide that?
I haven't actually seen the actual evidence for it.
Okay, well, I'm not trying to attack you or trying to anything. I'm just saying.
I know.
Well, but you just made the assertion that they do, and then you know what I mean. So I guess is that you conceding that you're not, that there isn't any of that, or you're not sure?
Oh no, that in no way can I with integrity say that it isn't there, and I concede. If I don't have the evidence at hand, the best I can say I don't have it at hand. It would be dishonest of me to say it doesn't exist because I currently don't have it.
Well, it would be
that's
dishonest
fair.
of you
Well,
to say that you know it exists and that I was wrong if you don't know it exists.
Yeah,
Exactly.
That's the
That's
part.
just
I'm not
false.
saying, I'm not like demanding you have to concede. I am just saying, though, you did say the words, yes, it does, you know, and now you're saying, well, you're not sure, and that's fine. If you just spoke overconfidently at the beginning, that's fine. But it sounds like, I'm not saying you have to concede to everything, but it does sound like you're conceding that you don't actually have verification of that measurement. You may have spoke too quickly, right?
I don't have it at hand, let's say.
And you don't even know if it exists or not.
Should be a quick Google search.
I do know it exists. No, it's not a quick Google search. Like,
why not?
Wait. If you know it exists, then what?
How exactly would you put it into words? Like,
Okay, then where did you read it or get it? I'll go Google it. Where do you think you read it?
Okay, how long will it take you to find it then?
Well, it totally depends on.
No, I'll look it up for you. Just tell me where you got it from.
No, I have a keyboard here. Rakia, since it's easier for you to find out the words, can you tell me what words you would use to search it?
To find out your evidence?
Yeah, no. I think
have no
real
clue
quick,
what you're talking about.
Laurie. The question was, I guess, why are you so confident in your answer of yes, it is, if you can't point even in the direction in which this evidence exists? That's how did you know this in the first place to speak so confidently?
I heard it in the conversations. I've been away from the conversations due to, for example, doing my BA thesis and being on third year.
So you heard
university.
gossip.
I heard good discussion, high intellectual discussion.
You heard it from who?
Highly intellectual gossip. I got you. Okay.
You heard it from who?
Yeah, from who? What physics forum or group did you attend?
Oh, I completely forget.
Okay. That's what I thought.
Can I ask for clarification? Is the thing that you heard that we can use can detect the rotation of the Earth around the sun? Is that it?
Yes, and it was using
muons.
No,
that doesn't do it.
That's one of the
it's
explanations.
using gyroscopes. I forget which type.
So, okay, I'll add clarity to it. I know the answer of what really happened. Okay, so when I debated first, it was FTFE had a conversation with him in Tartaria, and then destroyed him on relativity, and then he wanted to set up an official debate. Said he was going to bring the evidence because he claimed then that a gyroscope can detect it. I said, "What? To cite it? No, it can't." And he said, "Oh, I lost the paper. I'll have to bring it back to you in a week when we do our official debate." Then we came there, and he told me he didn't have it, couldn't find it, doesn't know where it is, but he's pretty sure he's read it before. Then MC Toon said the same thing in my debate with him, but also couldn't provide any of the evidence for it. So both FTFE and MC Toon just baselessly claimed you can use gyroscopes to detect the orbit, and then neither one of them could provide it, and ended up basically telling me they have no idea where it is.
I'm pretty sure Kosho's actually conceded this, that you couldn't measure it with a gyroscope.
Yeah, it doesn't sound right.
Yeah, well, they've used muons, and then they've used part of Lorentz contraction to try to explain it. Neither of those are measurements or are even validated.
Well, they don't even use that. They don't even claim that muons show Earth's orbit. They just claim that muons, like, since they're traveling so fast that they're able to be detected at the surface because their distance must have contracted, because based on their half-life, they shouldn't have made it all the way to the Earth. It's just about the muons movement. It's not even about the Earth's orbit.
Can I ask Kosho a question since he just joined and we're just spoken about him?
Yeah, but I can't talk very long, but yeah, what's up, man?
Yeah, can you detect the rotation of the Earth around the sun? I mean, the orbit of the Earth using a gyroscope.
Oh, I've seen something. I think indirectly, not exactly the orbit, but I know you can detect the tilt. But I gotta remember what I saw. So I don't want. Maybe I shouldn't speak on it right away. But I'll be right back because I gotta go for a second.
All right.
Okay, another thing I want to address while we're doing this is when this is the problem with just listening to FTFE and MC Toon, bro. And it's the same problem if fighters are just like listen to something I say, you know. But go ahead.
I actually want to address that. I would have done it previously already, but Bacon jumped in, and I wanted to give him the room. If what you're saying is correct, with it, and funnily enough, I don't have any good reason to doubt that it is. I will just straight up say that it's totally plausible that both FTFE and God damn it, I forget the name. The
MC2.
other dude that you debated, MC2. Oh yeah, totally plausible that they are wrong, and totally plausible that I'm just relying on incorrect sources on this one.
But if you're using that, that's great that you admit that. But if you're using them as sources at all for things like this, you might want to question that.
Well, this would maybe point that in that direction, right? But like, I want to point out, or Jeremy, you got something to say because I've been talking a lot.
What's up? No, go ahead. Finish it up.
So okay, so this part is one thing. So I had I had MC Toon just like flopping around like a fish, you know, and he was saying he was like, "Where are your measurements of stationary?" He was just like screaming it and interrupting me and repeating it, and I'm like, "What do you mean by measurement of stationariness?" You know what I'm saying? Like, how would you do that? Like, either you would measure something in motion and then you would measure that it stopped moving, or you would set up a test to try to measure movement, and then you would not get anything. You get a negative result, and that would be a quote unquote measurement of stationariness, right? It's like a silly question. And he said, yeah, so because I was saying that Michelson Morley did that, and he's like, no, it didn't. And then he kept saying to to give me give him measurement of stationariness. Anyway, so then he says, yeah, you would set up a test that is supposed to detect rotation, and then you'll see if you get a negative result, that's evidence for stationariness. Because he thought that was like a gotcha because he's talking about axial rotation. You know, he's like, yeah, set up a test for axial rotation and we're going to detect something. I got him, you know? And I'm like, okay, we did that. It's called Michelson-Morley. He said, no, Michelson-Morley wasn't about that. And I was like, yes, it's about the orbit of the Earth around the sun, which is a rotation. And then he just nervously laughed, ignored it, and then tried to change the subject, and then ended up trying to say that isn't rotation. Actually, he didn't even say that. Just the ballers afterwards said that that's not a rotation. All that to say, the funny part is I'm reading right here, section 5, which is what he alludes to in his quote about terrestrial experiments, and it says, for owing to the alteration in direction of the velocity of rotation of the Earth in the course of a year. So, like, literally Einstein is using the specific word rotation to describe the orbit. That's rough.
Yeah, I don't know what Kosho's going to check. I'm pretty sure he admitted before that you couldn't measure this orbit with a gyroscope.
Yeah, so I said a second ago. I said
Yeah,
not
you
the
can't
orbit.
measure it with the gyro, right?
No, I said you cannot. I said that there was something else about the orbit, and I can't remember if it was the tilt or what it was. I'd have to pull it up to see exactly what it was. But this big gyroscope was detecting, I think the tilt. But yeah, but I'm going to speak on
Can you
it.
measure the orbit with a gyroscope?
I said no. I never claimed that.
Oh, all right, yeah. That's what I
It
thought.
doesn't seem like you can. Like, I'm currently looking at articles from my university library. There is stuff about the rotation of the Earth, like on its axis. There's also stuff about the tilt. There isn't much. I found one article mentioning the sun and gyroscopes and the Earth, but I'm not very trusting that that's going to show anything promising.
So are you now more clear on what's going on here and why? Or do you hear? Yeah.
Is that a question?
In some ways, yes. I don't agree with its interpretation on the Einstein quote, but relating to gyroscopes and whether we can actually detect the rotation on, like, it would be stupid for me to die on a hill that I would die on. Like,
Right.
my stance on the globe is strong enough that I don't feel like I need to die on a topic where I know myself to be wrong.
I feel like you guys are in sinking sand, and I'm having to like drag you out of the sinking sand, and you're like fighting to sink. You know, like it takes a long time. It's kind of exhaustive. Like I just to recap, right? We're talking about the quote from Einstein because he said optical. I jumped in to say actually, there's also one that says terrestrial, and it says, you know, whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments. We've already remarked in section 5 that all attempts of this nature led to a negative result. And before the theory of relativity was put forward, it was difficult to become reconciled to this negative result, right? Like, as in every attempt on the Earth to try to detect the motion of the Earth around the sun has been negative. And before we put relativity forward, it was difficult to explain that, okay? And then when you go to section 5, that's where I'm reading the other quotes. It's like, it's literally, that's where it says, for owing to the alteration in the direction of the velocity of rotation of the Earth in the course of a year, which if I said that in a debate, dude, I'd get, it's word salad. For owing to the alteration in direction of the velocity of rotation of the Earth in the course of a year, the Earth cannot be at rest relative to the hypothetical system K proper throughout the whole year. However, the most careful observations have never revealed such anisotropic properties in terrestrial physical space, i.e., a physical non-equivalence at different directions. This is a very powerful argument in favor of the principle of relativity. It's literally saying that because every time we try and look at it, nature, and show that there is a non-equivalence based on the motion of the Earth's orbit, we failed to do so. They never show that. And the fact that it never shows that, if we are to assume that the Earth is in orbit, then the only viable way would be the principle of relativity. So that's actually a powerful argument in favor of the principle of relativity. It couldn't be more clear what's being said.
We were talking about this the other day. Somebody asked, there's a claim that we're moving a, 500,000 or 1,000,000 miles or whatever through space. Like, how do I test that claim? How do you falsify it? Whatever. They tried to rephrase it. Like, how do we test that claim to see if it's true? If it can't be falsified, what's up?
Just look at Andromeda Galaxy.
No, the only reason I even brought this up is because he said that the Earth movement is very clear and we've known it for a long time. And I was like, well, up till Einstein, apparently it's not very clear. He said that because if he has another way to prove Earth is, if he has any other way to prove that Earth is moving as with the same veracity that he's talking about everything, and now backtracking some things, did you want to backtrack this thing too, unless you have clear evidence of Earth moving?
Well, I'm interested on how we detect right now. Like, how would you and I go out right now and do a test and prove to ourselves conclusively that the Earth is moving? What's that test? Or 3 or 4 of those tests, right? There should be many. Can we name one?
I'm not actually sure about the orbit around the sun. Like the rotation.
Hello? I said Earth moving, rotating.
Hey, it's used to register.
Yeah, cool. I was talking, so feel free to interrupt. By the way,
you're talking about movement. We all said movement.
And then you said orbit around the sun. I said Earth's rotation, movement.
Yeah, and I wasn't confused about that. Like, I was making a point and you interrupted me rudely. Like, I was making a distinction between the two, and then you were interrupted me to say that there's a distinction between the two, and I'm talking like...
No, I asked a question.
Dude, yes,
I
you
asked
did.
a question.
And you should let me answer, fucking goddammit.
He heard it. Let him try to
for
answer
your
it.
bullshit, Rakia.
Okay, let me repeat the question because I don't think he understood. So I'll just repeat it just so we don't waste time. My question is, what test can we go out and do right now? There should be several, but just let's go with the top one that proves Earth's rotation, not orbit, not anything else, just rotation. Anybody want to answer that?
Rotation around its axis, or?
Yeah, around its axis.
Okay, well, that's easy.
Is it?
Like Foucault pendulum?
Pendulum, Coriolis, all that stuff, yeah.
Coriolis? We've been all over this. Like, that's why I was... I think you said motion or something, so I was talking about the... Because it's easy to detect the rotation of the Earth.
I also said
more difficult.
I also said conclusively because I think people in here could come up with reasons why the Foucault pendulum would rotate in a certain way, even at different latitudes.
But I think you can always come up with reasons why things would happen. Like
okay, so nothing conclusively then.
Yeah, but I mean, if that's the criteria, I don't think anything can ever be conclusive in that sense. That's why it's often said the science doesn't prove things, because there's always some alternative explanation that could explain it, right?
I'm cool with that, but if not conclusive, why do y'all fight for it so hard? I don't.
I don't know. I think it's strong enough that we should all accept it, but I don't know. That's
just accepted. Yeah. All right.
He said when he says not conclusive, though, he even just said it. He's saying he's leaving space for some other explanation, but that's because that could be true in any case. Like any case can have some alternative explanation, supposedly, but in this case, it's obviously the most likely, and obviously the only one that has an explanation for it. It's like that Coriolis and Foucault's pendulums and Michelson Gale and all these other type of tests. They
So
all
let's just
say
take
the same thing.
the Foucault pendulum, Coach. So you're a smart guy. The Earth isn't spinning; it's stationary. What would make the Foucault pendulum precess in a way that you would perceive? You would see it moving. If you knew the Earth was stationary, is there a reason you could come up with why the Foucault pendulum would precess?
There's some force I don't know about that rotates around the spherical Earth. Yeah,
But that wouldn't work because the force only shows up when the thing is moving. It doesn't shows up when it's not moving.
well,
It
yeah,
has to be a
that's
force
true.
that is motion dependent, which is very hard to come up with an explanation for.
So I'm saying this force, though, it specifically affects pendulums in this way, also. So it's like it's like an unknown magical force that specifically rotates around a spherical Earth, and also affects pendulums for some reason.
So that's the only way. A magical force that we don't know about.
Yeah, well, it's either magical or we don't know about it, but yeah.
So
Not saying
nothing
it's
that
actually
we know,
magic.
nothing that we know would make something precess on a stationary Earth.
Well, if if you're considering that it precesses according to the sign and the latitude, I can't think of anything that can make sense other than that.
Okay, take away that. Anything that would make it precess?
No, I can think of anything.
Fair enough. Good luck.
I mean, can anybody? Because it does precess based on your latitude. Yes.
Have we ever checked to see if that was the cause of the effect? How would we check for that? I'm just curious to see if that was the cause of the effect.
You would
Easier said
stop
than
the
done.
rotation of the Earth.
No, you would just do a different test to see if it was rotating.
Oh, all right, cool. Let's have that one then.
Okay. I mean, we can get, like I said, this is cheating. I don't like to bring this up, but I consider it cheating. But there's Epic Discover, which is a freaking thing that takes pictures of the Earth from technically a reference frame that's independent of Earth's rotation, technically, because that it can observe the Earth rotating. So that fact alone will corroborate the Foucault's pendulum.
So, but nothing that we can actually check, or just some satellite, and we have to just believe what they're sending us, right?
Satellite that takes pictures, but yes, other than the pictures coming from the satellite, the images of the Earth rotating.
Maybe the images are real, maybe they're not. Who knows?
Yeah, maybe, yeah. Other than that, though, there's the other
We can
test.
trust the government, though, for sure.
Yeah, I mean, you don't have to trust the government to,
Who's running these satellites?
people who work for the government.
Oh. So, just trust the government on this one?
Oh, I don't know. Like I said, depends on how you want to square it. But other than that, there's other tests you can do. So there's all the
like what?
Well, I mean, you can observe.
Come on, real quick, before we're off the Foucault pendulum. Which way is the Foucault pendulum? We're seeing the Coriolis effect, right? When we see that.
First of all, you already know my answer, man. I don't know why you would ask me this.
I'll take the bait. All
right, you take the bait, but I don't know. I'm just curious why he would ask me when he knows that I fucking confirmed him about this. But go ahead, Bacon.
To hear you squirm.
Squirm.
Not answer. Because
All
you know there's an audience. You know it's not just you and Jeremy, right? You think
Go ahead,
there's not a
Bacon.
reason? You think we're all stupid, right? You think there's not a reason we ask these
No,
Why
let's
do you
not
guys
go
always
there.
say that, dude? It's like you
Yeah,
guys.
let's not.
It's like you guys have this opinion about yourselves, and you put.
What do you mean? What do you mean? You're the one who said.
All right.
I don't know why you're gonna.
Okay, let's just focus
not
on
go
the
there,
topic. Yeah.
Foucault pendulum. That's why he's asking you the question. You decided not to answer. You started it. Yeah.
We're done with that
Me and
conversation.
Kosho have
We're
been
just
through
gonna
this
talk about
before.
pendulum
So.
now.
Yeah, let's
Yeah,
stay
but
focused on
Kosho
the
could
topic.
answer it for the audience, right, Jeremy? In
Well, he didn't
DC.
want
Sure,
to.
he
I will
did.
when Bacon's done. But
Yeah, he already did. Yeah.
Me and
Jeremy
Coach have
already
been
asked you
through
that
this before.
before.
Bacon wants to crack, maybe.
Yeah, go
Go
ahead.
ahead, Bacon. Good luck, buddy.
Thank you. I'll need it. Go ahead, Jeremy. Hit me.
So, which way does the Foucault? That's the Coriolis effect, right? Foucault pendulum. This is the
Yeah,
Coriolis
it's
effect,
caused
right?
by the Coriolis. Yeah.
No. Yeah, it's the Coriolis effect we're seeing. We're seeing the Coriolis effect, right?
Yeah, we could say that. Yeah.
Well, that's what they say. I don't know. Anyways, which way is the deviation?
East when you go north, west when you go south.
In the Foucault pendulum, it's in the south. It's going east.
No, if you move north in the northern hemisphere, it deviates east. If you go south, it deviates west.
In the
In the northern
Foucault
hemisphere.
pendulum, we're talking about the Foucault pendulum. Which way is it? Is the Coriolis deviation happening?
It depends on the hemisphere.
Okay, well, let's do the north.
Right. So the pendulum deviates eastwards when it's moving south, and westwards when it's the opposite. It's eastwards when it's moving north, and westwards when it's moving south.
Do they usually call that clockwise or counterclockwise or anything?
Yeah, that ends up causing a clockwise precession in the pendulum.
Clockwise. So the deviation is clockwise.
Yeah, in the
Coriolis
pendulum,
effect deviation is clockwise in the
in the
pendulum.
pendulum, yeah.
Yeah. Does the globe predict in which hemisphere the Coriolis deviation will be?
Yeah, I said it's eastwards when you're going north and westwards when you're going south. That's the deviation that it
Is
tells
that
you.
clockwise or counterclockwise? Just for
In
the
the
audience.
pendulum, that's clockwise.
Yeah, but which way is that? And that's the way the globe predicts it.
Yeah,
The Coriolis deviation in the northern hemisphere will be clockwise.
with the pendulum, yeah.
Well, it's not like there's a different Coriolis thing happening, right? It's
I
just Earth
agree.
rotating, causing the Coriolis effect, right?
Exactly. Coriolis doesn't say clockwise or clockwise. It tells you that if you go north, it's eastwards. If you go south, it's westwards. If you put that on a pendulum, it creates a clockwise precession. Because the pendulum is going back and forth. So every time, if you're going back and forth, every time you go north, you go right. Every time you go south, you go left. That turns into clockwise precession.
So the Coriolis deviation for the Foucault pendulum is clockwise.
Yeah, in the northern hemisphere, yeah.
In the northern hemisphere, yes. Which way is it for hurricanes?
It's counterclockwise.
Counterclockwise. So we have the same effect. Two different things are happening now.
No, the things that in the hurricane are also going eastwards when they're going north and westwards when they're going south. It's just that the hurricane is an inward motion, and that because of that different dynamics, that same effect becomes counterclockwise.
What causes the hurricanes to go clockwise, counterclockwise?
The same effect.
Coriolis effect.
Yeah. So when the mass is moving inwards to inside of the hurricane, the air that is moving north deviates east, just like the pendulum, and the air that is going south deviates westward, just like the pendulum. But that's an inward motion. If you draw that, you're going to see that that's now counterclockwise.
Okay, so we have the Coriolis effect, the deviation going clockwise for the pendulum, right?
Mhm.
The Coriolis effect deviation is going counterclockwise for the hurricanes, right?
Yeah.
Okay, it's the same effect. It's the Coriolis effect.
Uh-huh.
It's happening in two different ways in the same hemisphere.
Yeah. Because it's two different dynamics. One thing is going back and forth. The other thing is an inward motion. If you apply the same effect, which is the Coriolis effect, to an inside motion, that becomes counterclockwise. And if you apply that to something that is going back and forth, that is clockwise. Same
Are there
effect,
any other
different
examples
dynamics,
of onward motion?
opposite rotations. That's simple.
Yeah, just like this image I made for you when we talked about this the first time, Jeremy.
Hold on, Kosho. Hold on, man. You had your chance. You had your chance. You blew it. You passed it off to Bacon. Relax. We went through this anyways. It doesn't change the fact that you have the Coriolis effect. That's one thing that's happening. You have two different deviations happening. One's clockwise, one's counterclockwise, but it's supposed to be the same effect. But yeah, it's the opposite, opposing directions.
Yeah, as I explained, because there are different dynamics, it's different motions, then that's exactly what you would expect. because what
It's the same
Coriolis tells you.
dynamics. It's the Coriolis effect.
Yeah, but the Coriolis
Different.
isn't.
It's not different. It's the same.
Yeah, but the Coriolis is doing the same thing. Whenever something is moving northwards, it's getting deviated eastwards. Whenever something is moving westwards, it's moving southwards, it's deviating westwards. That's happening in both Foucault's pendulum and the hurricane. What happens is the pendulum is something going back and forth. The hurricane is things moving inwards. Because those are different motions. One ends up being clockwise, the other ends up being counterclockwise.
Sorry, your first sentence, you said it was doing the same thing. It's not doing the same thing. It's doing the exact opposite thing. It's the antithesis of clockwise would be counterclockwise. No, I don't want to get bogged down in that, but it seems like the exact opposite thing. So just to correct your first sentence that you said, definitely not the same thing as doing the complete opposite thing, because one's clockwise and one's counterclockwise.
No, what Coriolis is doing is the same, but you're doing the same thing in different mechanisms. So the end result isn't the same. So if you're doing the same deviation in a back and forth motion, that is one rotation. If you apply that same effect on an inside motion, that becomes the opposite rotation. The same effect in different types of motion have different outcomes. So what Coriolis is doing in both cases is the same, but both cases are different. And that same effect ends up with different outcomes because they're different setups, they're different motions.
I'll just run it back for the audience. I'll just run it back for the audience real quick, and then I'll back off, and you guys can go ahead. But thanks, Bacon. So we have the same effect, the Coriolis effect. It's causing two different directions. One of them's clockwise, one of them's counterclockwise in the same hemisphere. So it's not doing the same thing; it's doing the exact opposite thing from each other. That's all.
It is doing the same thing, but it's doing the same thing.
Doing the exact opposite thing, clockwise and counterclockwise. One of them's what you said. What the deviation is clockwise in one, and then it's counterclockwise in the other one.
No. I said the deviation is eastwards. For whatever thing is moving.
Direction that was. They can play the tape back if they want. You guys can play the tape back. It's fine. Go ahead, Bacon.
I have a question, Bacon.
It's fine.
I have a question.
Even two.
So you're saying if a what is it? A storm, a hurricane in the northern hemisphere, swung back and forth, it would go in the opposite direction.
Well, it's not that the hurricane is moving back and forth. It's during the hurricane formation, there is a lot of mass of air going inwards, entering the hurricane. So when you have an inward motion and apply Coriolis effect, that gives you the counterclockwise rotation.
Which way is the storm rotating in the northern hemisphere?
Counterclockwise.
And which way is the pendulum rotating?
Clockwise.
And the only difference is the inward motion of the air is making it circulate one way due to Coriolis, and the swinging of the pendulum is making it go the opposite direction due to Coriolis.
Yeah. I mean, it's not. Let me see if I can help you picture that. So
no. You don't have to help me picture it. I just wanted you to say it again.
Well, that was already said.
Right, I know. I said again.
Again, as I said, the prediction of Coriolis isn't if something's going to deviate clockwise or counterclockwise. It doesn't define a clockwise or counterclockwise deviation. If you try to define like that, you can try to come up with a contradiction like this. But that's not what Coriolis does. Coriolis deviates things eastwards or westwards, depending on if you're going north or south. And if you apply that same thing to a back and forth motion, it does the opposite. That if you apply that same thing to an inward motion. So that's not a contradiction. That's just the fact that you're using the end result and calling that Coriolis, when in fact Coriolis is in the beginning.
So the pendulum only swings outwards; it doesn't come back inwards.
No, it goes back and forth. So
right,
if me and you are playing,
so the wind of the storm only goes inwards; it doesn't come outwards.
During the formation of the hurricane, there's a lot of mass moving inwards into the hurricane.
Which causes rotation, right?
Yeah. Yes. And if
so
you apply
the inward motion is caused by Coriolis, and the rotation is caused by what?
No, the inward motion isn't caused by Coriolis. The inward motion is caused by the formation of the hurricane. When you have a lot of humid and warm air going up and
Yeah, it's
forming
actually up
column.
and down. It's not really inward, right?
No, but usually, as at least that's how I understand formation of hurricanes. I'm not an expert on that, so I might be
Yeah,
I may be
obviously.
wrong.
You've just heard this argument. You know how to repeat it.
No. I'm talking about the formation of hurricanes.
Come
When
on,
the
be
air is
honest.
going,
Be honest now.
I am being
So
honest.
you just said you weren't an
I didn't
expert
finish
on the
either
formation of hurricanes,
my last sentences,
but
and you're
yet
telling
you
me to
know
join me.
that Coriolis is causing the inward. Well, when the wind goes inward, Coriolis is causing the opposite direction of the storm in the northern hemisphere.
Yes.
But yet you're not an expert.
That part, I'm sure it is the explanation. I've already seen that before many
Maybe
times. No,
maybe
what I
it's
said
what
I
I said.
wasn't. But yeah,
Yeah,
what I would
maybe you just heard this explanation and now you know how to repeat it.
no. What I'm not sure about, because you take expertise on the subject, isn't about how Coriolis is applied on a hurricane. Coriolis doesn't matter if it's applied to hurricane or for pendulums or for bullets. It's the same thing. You don't have to be an expert in bullets to be able to predict what's going to be the Coriolis effect.
Yeah,
But
no,
when
I
you're
agree with you. I don't have to be an expert in bullshit
Let me
to
finish.
tell
Let me
you how
finish.
this is just bullshit. Sam.
Rakia, let me finish.
You know
If you're
these storms are created by the wind.
okay, if you're talking about the formation of the hurricanes, that has nothing to do. The formation itself isn't tied to Coriolis, and that's specifically to knowledge of weather that I don't have. So when I talk about what Coriolis is going to do to a hurricane, that's not knowledge from weather. That's not knowledge from climatologists. That's just knowledge of Coriolis. That I can claim. So yeah, I'm not an expert on how hurricanes form, but I understand Coriolis enough that I can tell what's the direction that they should apply to the hurricane, given how the basic idea of its formation.
No, that's just what you've heard, right? Because
What I heard is about
storm.
how they form.
Now you're over talking me when I was muted for some
I
reason.
thought you asked a question.
No, I was clearly
Just go
making a
ahead.
statement. Yeah, I don't mind if I do.
He's
I don't
mad.
need you to tell me. Yeah. So storms that happen in a certain time of year only, form in a certain region only, form because of the weather patterns, high and low pressure that are coming in at a certain direction, and create these currents along with the wind patterns of the trade winds of that area, which create the certain rotation, which is going to happen every time, because every time that year those storms come in from certain directions.
Okay.
Right? You agree with that, right?
I don't know. I can take that. Yeah. So
What do you mean you don't know? How can you
yeah.
be talking about the rotation clockwise or counterclockwise in any hemisphere if you don't know how those exact storms are formed? You know hurricanes aren't formed as hurricanes, right?
I don't know much about that.
Obviously you don't. I'm done with this guy.
All right.
All right. I mean,
So,
all I know is that there's mass moving inward. That's what I've found when I looked up into the formation of hurricanes. And that's all you need to apply Coriolis. It's just to know what direction things are moving. Once you know that, then the rest of it is irrelevant. You can try to talk about the specifics of the rest of it, but that's not going to be impacted by Coriolis. Just
So
the
then-
direction of the motion.
So
the
then
Coriolis, if the cause is the same, hold on a second. If the cause is the same, which would be Earth rotation, and we're getting the Coriolis effect, it would deviate in the same direction every time. Now, you told me one of the deviations was clockwise and the other deviation was counterclockwise.
It's a different mechanism. The deviation isn't the Coriolis. Yeah, Coriolis isn't doing clockwise or counterclockwise thing. It's doing eastwards and westwards things.
which
I think-
creates a clockwise or counterclockwise in that theory, depending on the north and south.
Exactly.
But Jeremy,
But-
he's trying. The explanation he read off the internet is that it's because of the inward motion of the hurricane pulling together that changes it from clockwise to counterclockwise in the north. That was what he was saying.
Yeah, I mean, whatever. The cause, we have the same effect and the same cause. So I mean, whatever, you can try to twist it whatever way you want, but the fact is we have the same cause, the same effect, different outcome.
But the next thing I would ask to Bacon is, Bacon, how do you know that the Foucault pendulum is inward or outward?
The Foucault pendulum is back and forth. So if you picture two people, one north of the other and the other south of the other, and every time they throw the ball north, it gets deviated eastward, and the other person has to go a little bit eastwards to pick it up. And when that person throws that ball back, if it deviates westward now, that other person that is at south of that is going to have to go westwards to pick it up. And if they keep doing that, that's going to create a clockwise rotation. At the same time, and now to explain the hurricane, if you don't mind.
All right, well, yeah, but here I just posted an image. That's like on the globe, the way they claim, clockwise, counterclockwise, hurricanes, spin of the earth. So how are you going around this and trying to claim that some kind of inward motion is going to change that entire direction? So now Coriolis is now going the opposite way just because of how does inward change that?
Right. Okay, so did you understand the back and forth ball thing? That would be clockwise, right?
Yeah, I understand the theory.
Right.
On
Okay.
that, yeah.
So, but now if you have two people, one north of the other, same initial setup, but both of them have a ball, and both of them throw the ball at each other at the same time. If the same deviation happens, the person that is throwing the ball north deviates eastwards. The person that is throwing it south deviates westward. And if you look at the path of that ball, when it gets close to the middle, which is like would be analogous to the air getting inside of the hurricane, though the deviation between those balls is now counterclockwise. The same effect, same deviation, but it's a different motion. It's two people throwing the ball inwards instead of they throwing back and forth. If you follow the path of the ball, the deviation that they both create in the center is counterclockwise.
Can I just ask a quick question?
Me?
Is the discussion just that is just if you're talking about Coriolis, I feel like that I never hear anybody talking about the cause of this effect that we see.
I just said it. My last statement said the cause was Earth rotation, and they're dynamic. You have the same cause for both of them, same effect for both of them, except it's
because
not the
Earth
effect.
is what? Because the
except
Earth
it's not the same effect.
is not. Yeah, right. It's not a square or a cylinder, right? It's a sphere. It would have to be a sphere.
In your model, it's a sphere. Yeah.
We wouldn't see the type of Coriolis effect that we see.
The type that goes in different directions from the same cause.
Right.
Right. Like even in their model, like a hurricane, let's say coming up off the coast, like headed towards Florida, the hurricanes will go up the coast of the United States, like up near, up to New York, up to Maine, and then it dissipates. So those make a clockwise movement across the earth, from the equator, up the coast, up to New York, and it's making a clockwise. So the path of the hurricane will go clockwise. However, they claim in their, that the actual spin of the hurricane is going counterclockwise. So it's spinning counterclockwise while it's moving clockwise across the earth.
I just wanted to add one more thing. I have to go, but yeah, we still haven't talked about the cause. Yes, it is the Earth rotating, but that's not really the cause, right? It's still conservation of momentum on a sphere.
No, that's not the cause of Coriolis
It
at all.
is.
All right.
It's because the tangential speed. It's because the tangential speed at the equator, right, is much higher than it is north or south of the equator.
Okay, is it angular or linear conservation of momentum?
I have to go.
Because I can show you an example where the conservation of momentum doesn't come into effect. Would you want to go through it real quick, or it only takes a second?
He left. The answer is linear.
Yeah, but I can show you the example where the conservation of momentum has nothing to do with the Coriolis effect.
Please.
Okay, I mean, you guys have heard this about 100 times now. There's two guys in a park throwing a ball back and forth in a straight line. All right?
Yeah.
Yep, they're throwing it back and forth. Some guys come in, construct a roundabout in the middle of them. Kid gets on the roundabout, merry-go-round, starts spinning. Now we see the Coriolis effect.
Mm-hmm.
Yeah.
Yeah, it's not the conservation momentum has nothing to do with the fact that he
Yes,
saw
it
that.
does.
Oh, of course it does. Okay, can
No,
I
it doesn't.
explain it? What would happen?
Oh,
What
you
would
think
happen?
that's funny?
Yeah.
Yeah. What would
Okay.
have to happen for that kid that is rotating the roundabout to see the ball make a straight line? The ball would have to
He
deviate
just
from its path, right?
okay. He just told me that was the cause of the Coriolis effect was conservation of momentum. Right?
Yeah, in a
You guys are
rotating.
going. Are you guys going with that?
Yeah, on a rotating
That's the cause.
reference frame. Yeah.
That's the cause of the. Okay, go ahead. Let's go through it.
Yeah. So if for that person not to see a deviation, for the ball to make a straight path in the person that is in the roundabout, that path would have to deviate from the trajectory that it was thrown. So that would violate conservation of momentum because there's no force doing that. So, but the ball
Yeah, there's
doesn't
no
do that.
force.
It just moves in a straight line because of conservation of momentum.
Yeah, it moves in a straight line without it. So I mean, it didn't cause any Coriolis without when they were just throwing it in a straight line. What causes Coriolis is the differential and reference frames.
It goes in a straight line without it in the inertial frame. In the non-inertial frame, it makes a curved path.
Yeah,
So
like I said, the frames. You need the frames is what causes it,
Yeah,
not
but
the conservation of momentum.
you need both.
when you ask it, I complimented I and said that it's a conservation of momentum in a non-inertial frame reference.
Dude,
You can go
nothing
back in the
changes in
Livestream.
the. Okay,
Sorry, go ahead.
nothing changes in the conservation of momentum when the guys are throwing it in a straight line the way that it does when the guys jumps on the roundabout and sees the Coriolis effect happen.
Well, in that case, conservation of momentum is simply telling you that the ball's going to move in a straight line in the inertial frame, which has to happen because that's how the kid that is in the roundabout sees the curve, because they're in the rotating frame. So if the ball is going in a straight line in the inertial frame, which conservation of momentum tells you should happen, then that kid is going to see a deviation. So yeah,
But it doesn't have anything to do with the Coriolis effect because that conservation of momentum was there before and it'll be there after the kid stops rotating. That's not the cause of the Coriolis effect. You need the differential and reference frames. Has
no, I
nothing
mean,
to do with conservation of momentum at that point because the guy throwing the ball back and forth, yeah, the ball conserves momentum. That doesn't cause the Coriolis effect.
kind of does. Like if
the
the
guys,
ball
okay, do
makes
the guys see the Coriolis? Do the guys throwing the ball back and forth? Do they see the Coriolis effect? There's conservation of momentum happening, right?
yeah, but they're not in on the rotating frame.
Of course, because that's what you need. You don't need
You need both.
conservation of momentum. Well, yeah, that happens anyways. Conservation of momentum happens anyways.
Yeah, but if you don't have conservation of momentum in a rotating frame, then Coriolis isn't guaranteed anymore.
Yeah.
If you throw a
you
ball,
don't-
if you throw a ball and that doesn't preserve momentum, it could very well make a straight line in the rotating one.
Okay, first of all,
Why don't you guys just meet halfway? Go
nope,
ahead, man.
absolutely not. You had your shot, Coach. You blew it. Okay, you need a baseball for this to happen too. All right, yeah, you need conservation of momentum in a baseball, but the cause of it is not the baseball or the conservation of momentum or the guy's hand when he's throwing the ball. You have to have the reference frames to differential in the reference frames is what you need because the guy standing on the ground, there's conservation of momentum is there. If that was the cause of it, they would just see it. It's not the cause of it. You have to have the differential and reference frames to have it.
Yeah, we agree that you need a rotating reference frame, but it's not wrong to say that you also need conservation of momentum.
Yeah, but it's not the cause of it. I asked right when you started this, you guys are saying that's the cause of the Coriolis effect. You were like, yeah.
Yeah, I said
and
yeah.
now we agree that's not the cause.
Yeah, I said it's conservation of momentum on a rotating frame. If you have something moving a rotating frame and momentum is conserved, then you're going to experience Coriolis. If you don't have conservation of momentum, then I can't predict what's going to happen.
You always have conservation of momentum, bro. That's not even an issue. The cause of it, like Damon's tried to say the cause of it, the cause of the Coriolis effect was conservation of momentum. We now know that's not a true statement though, right, Bacon?
I wouldn't agree with that.
So you think it is
Part
the
of it.
cause of it? So
It's part of it.
it's always there, dude. It's always there. What do you mean part
Yeah,
of it? The
because it
baseball.
has to be
So you
there.
think the baseball is part of it? And that's throwing
And
the ball is part of it?
and in that scenario, yeah. What do you mean?
Okay. Well, I mean, never mind. If that's the lengths you want to go to think these are the cause of things, then whatever. I guess.
He can't
right.
admit it. He can't admit it.
The
So in
guy's
other words,
hand.
what you're saying is it's a visual effect, correct? Correct? This is where you get him, Jeremy, right here.
It's a frame dependent effect. If that's what
So
you
it's
mean
a
by
visual.
visual, then yeah.
Yeah, visual.
So it's not actually. Yeah, there you go.
Actually,
End
hold
of
on, real
story.
quick. When I described that scenario to some of your Glober guys, they said that's not the Coriolis effect. I actually had to get rocket scientists from GEMS to do the math, and they still didn't believe him. There is a lot of people walking around right now who have heard that scenario. They do not think it's the Coriolis effect. Most of them are on your side.
Most people are on our side. That's not a fair thing to say. But you know, I've always been on your side about that because it's obvious. But what
It's
Bacon
obvious,
and Damon
right?
are saying, yeah, to me it's obvious. But what Bacon and Damon are saying are more obvious than that, and that's that Coriolis, like it described, it's the deviation of an object as viewed from a rotating frame.
Apparent
Because
deviation.
That's right, Jeremy.
Well, no.
You tried to slip that
No,
in.
it's not just.
You
It's
tried to
not.
slip
No.
that in.
Yeah.
I didn't say. I'm not
let him
using.
finish.
I'm not using the word apparent. I'm not using the word apparent because
You
that
have
would
to.
be
Not
people
actual?
like you, people of your ilk, your kind. No, I'm just kidding.
Ilk.
But it would lead you people to believe that it's not actually happening, and in actuality, it is actually happening.
You know what Bob
it
told
is
me?
the
You know what
concept.
Bob told me, Kosho?
Yeah, that it was optical
And that's
illusion.
not
And
actually
regardless,
happening. It's an optical illusion. I think those were actually Bob's word verbatim. That's
Optical
not
illusion?
actually happening.
I don't
It's an
think
optical
anyone
illusion.
other than Essie and Rocket would call it an optical illusion.
It is absolutely an
I've
optical
been
illusion.
saying that for
Bob,
years.
When
I
Bob,
called it an optical illusion. Bob, the science guy, called it an optical illusion.
Yeah,
The
I didn't
force,
see
I
that
don't.
coming.
the force is not
Yeah, I
even
don't.
real. It's the force you calculate. There's nothing real about this.
It is real. It's the real path that's going to be taken from that frame. All motion is relative, and it's reference frame dependent. And if you're describing the motion from that reference frame, it turns out the Coriolis that what you're required to describe that movement is actually real. That's real movement. It's really how the path is defined in that reference frame.
So is the
Regardless,
Coriolis force real? Is that a real force?
it's a real force. I consider fictitious forces real forces. That's because they're a subset of
There's
forces.
actually a force
Even though
pushing the ball off its straight line path. That's what you think.
the force is actually the force is actually reference frame specific, but regardless, it is a
That means not actual.
not actual.
No, it doesn't mean
Too
not
easy,
actual.
Coach.
It doesn't mean
This
not
is
actual.
over, bro.
It just means
At
not
least-
universal.
So
At least the
Jeremy,
acceleration.
say your question again.
At least the acceleration
on.
should be.
Go ahead, Jeremy. Say your question again.
It was a
So the
statement.
ball's actually being forced off the line that it's
Yeah,
thrown
so
on.
if you think
Yeah.
it's a real force,
Right, Kusha?
is there an actual force pushing the ball off its straight line path? Because that's what a real
There's
force
not an
would do,
actual
right?
pushing force. No, yeah, that's what a universal force would do. This is a reference frame dependent force.
So the ball's not
This-
actually moving. So the ball's not
the
actually
path-
moving
the
off
path-
its path,
the-
right?
the-
It just
No,
appears
it
to
is.
be.
No, there's a different path. It's a completely
So it
different
is
path.
being forced off its path.
Yeah, Kosho.
So
No,
it
it's
is
not
being forced off
Not
its
being
path.
pushed. It's not being pushed. It's just a different
But it's
path.
being forced,
described
I
in that
said.
reference frame.
Forced off its path.
Stop
It's being
interrupting.
forced
Rocket.
off its path.
Yeah, hold on, man. If they were interrupting like you like this, you'd be freaking out. Just let them finish. Then I'll give you the floor. Go ahead, Rocket.
No, I'm trying to get whether it's a force or if it's just
Nah.
an apparent the way it
Not a
looks,
force.
right?
Yeah, it's not a force. Even Dr. Bob, when I described that thing to him with the merry-go-round and the two guys in the park, even Bob said that's not the Coriolis. In fact, we can go to GEMS right now. I bet you I'll get 10 people to say that's not the Coriolis effect. It's just an optical illusion.
That's fine.
Can I try to offer a better phrasing for Kosho? I think, yeah, I think it's much easier to argue that the acceleration is real, because that's entirely, like, its acceleration is entirely frame dependent. But force is
So
more
now,
dude.
Hold on.
Force is more
I thought you were done, bro. This is very
right.
simple.
Okay, so the force is more like of an interaction, and that interaction doesn't exist. There is no interaction causing that acceleration, but acceleration is there. We just attribute that acceleration to a force if we know the mass of the thing. So I would say it's fair to say that the force doesn't exist, but at least the acceleration should be granted that it does exist.
So the
This is what I-
acceleration
this
has
is what
to
I meant by-
change now.
Hold on.
Wait,
let Rocky
can
go.
I respond to that?
Yeah.
So
hell
now
yeah,
it's
go
the
ahead.
acceleration of the ball or the object moving in its path that's changing, right?
Yeah.
Wow, man.
Well, it's
Do we
kind of
know
the
how
same
to throw a
thing.
ball? Hold on. Do we know how to throw a ball in a straight line on Earth? Do you
No,
guys
it
think
makes a
that's
parabola
possible?
when you throw it. No, when you throw it, makes a parabola.
Okay, despite the parabola, do
Sorry,
I know
yeah.
how to throw a ball and not let it curve left to right? Can we throw a ball straight,
Yeah.
not curving left to right?
Yep.
Yeah. So we definitely know when we did that, right?
Yep.
Yeah, so when you get on a roundabout and spin around, we know that actually is not taking a curving path. We know that actually is going straight, and the deviation is just an optical thing caused by the reference frames and conservation of momentum. And the guy's hand that threw the ball.
Well, you'd
Well,
have
in
to.
that,
And the
the path of
acceleration's not changing.
the path of the ball is curving left or right in the reference frame.
Yeah,
Yes,
you'd have
optically.
to assume that there's a universal reference frame that you're viewing this all from for that to be true, Jeremy.
So
Actually,
we don't
you
know
don't
how
need
to
that.
throw a ball in a. So you're saying we don't know how to throw a ball in a straight line on Earth?
Well, it depends on who's viewing it.
You don't need an objective frame of reference. You just need an inertial one. You can say, well, even though I'm seeing the ball making a curved path, I know that in an inertial frame, I know the ball must be going straight. That's fair. That's completely correct. But it doesn't change the fact that in your frame of reference, the path of the ball is curved, because that frame of reference
but
is
that's-
rotating.
It's optical.
Yeah, but
So which one's actual and which one?
Yeah.
Yeah, there's no actual frame of reference. They're inertial and non-inertial.
That's Jason's point. That's Jason's
So
point.
we don't know how to actually throw a ball straight on Earth. So that's your argument. We don't know how to actually throw a ball straight on Earth.
No one said that.
Is that your argument? It sounds like that's what we're arguing now.
Why would you
All
think?
right, so
Let
we
me
do
get
know.
this question in if I can. So you guys ballers, you're saying now, do we understand this clearly? Are you saying that the ball is both traveling in a straight line and curving at the same time?
No, because the people
observing
it are either in one, or they're in one of those reference frames. So it's only doing one thing for them. You can't be in both of the reference frames. You can't be in both of the reference frames watching both things happen. That's not how reality works. You're in one of the frames watching one of those situations happen.
We can actually record. We can actually record. Hold on, we can actually record both of the reference frames happening at the same time and then play it back and watch it. We can have two screens set up side by side and watch both.
Yeah, but that's not you
frames at the
observing
same
it.
time.
Not yet, but what does the ball do?
That's not you observing
Not yet,
it.
but
That's not
what
you
does the ball
observing
do?
it at the
That's an observer.
real time.
Hold on, Rocky. You're next.
No,
One at a time. One at a
not.
time. Just one at a time. One at a time.
It's a recording. You're not watching in reality the ball again, and now you're in a different frame watching it. That's not what's happening.
So now
you see what you see from your frame, and that's that. Now
Yeah,
you can record it
yeah.
from another frame and watch it later, but you're not witnessing two realities at the same time. You're watching a recording. I don't know how you can't distinguish
The
that.
ball either goes straight or it doesn't go straight, no matter who's recording it.
Are you
Now, it
saying
might
that when we
appear to
record
curve.
this?
No, I mean, it does matter.
Go
Rocky. I
ahead,
just want to
Bacon.
point out for the
You
audience.
can
Hold on,
handle
can you guys
this
hear me?
silliness.
Check. Can you guys hear me?
Mm-hmm.
Point. I just want to point out for the audience the ridiculousness that this conversation has now went into, that when we're recording something, we're somehow not recording reality or something, according to Jace, right?
No, that's not at all.
That's your argument
what
now?
I said, it's just a silly straw man.
So we can
Tired,
record.
really.
Okay, cool. So we can record reality and then watch them both happen at the same time, right?
Yeah, sure. It's a recording. You're not watching both things happen in real time, is what I said. Because you're just one observer watching one reality, and that's how the reality works. It doesn't work any other way.
Well, we can set
Fair
up
enough.
two
Now, this is
TVs.
the question. Jeremy, let me ask this, please.
Go ahead.
How many
Unbelievable.
motions does the ball have in reality at one given time? How many motions does the ball have?
How about an infinite number?
No, in the scenario we're talking about, you throw a ball in a straight line, right?
Yeah.
That ball, how many motions does it have? Irrespective of the reference frames. We'll get into that after.
Well,
How
see,
many motions
in
does that ball
there
have?
lies the assumption that there's a universal when you say irrespective of the reference frames, that's you're assuming that there's this universal frame we can just compare all motion to, and it's arbitrary. And that's not how reality works. The motion is relative to your frame, to you as the observer.
Okay, so your argument is, hold on, SE, real quick, bro. So you're saying we don't know how to throw a ball in a straight line? That's what you're saying?
No, that's not
No,
at all what I said.
No, he was saying it's an assumption that it's a universal reference frame, but I would say it's not an assumption because you have a base ball being thrown through the air. That's your reference frame. It's not an assumption or just a random leap of logic that there's one reference frame. It's the reference frame because it's a ball within air.
Well, Jeremy gave you why that's not right before with his merry-go-round example. You can be on the merry-go-round and you see the ball going through the air doing one thing. While you're not on the merry-go-round, you also see the ball going through the air doing a different thing. Because it's dependent on your frame and your motion relative to what you're observing. That's just how reality works.
The difference is in my scenario, we knew that the ball was going in a straight line because the guys were standing on Earth throwing it in a straight line. And your argument is they don't even know they're throwing it in a straight line because there's no actual reference frame.
Can I ask you guys a question?
Jeremy's thing did have the base reference frame. The guy's throwing the ball. It's a secondary reference frame to have other guys or other people on a merry-go-round. That's like a reference frame within the universal reference frame.
Well, those are two different observers. So the description is always going to be in reference to some observer or some observer's frame.
Yeah.
But just let me ask my question very quickly because this maybe will elucidate something. But yeah, if you have the same ball, if you're on a cruise ship, okay, and the cruise ship has bumper cars, okay, or something, and the bumper cars are they're weird bumper cars and they go back and forth for some reason, like a accordion for some reason. I don't know why they're doing this. Anyways, if you were to shoot a BB gun from one of these, carts.
Worst analogies, Jeremy.
Well, hold on.
Ever, bro. And Kosho's
here's the question. Here's the question.
Top 5. Go ahead, Kosho.
I interrupted.
Give me your ranking when I'm done, Jeremy. Because in this scenario, when you shoot that BB gun, how many speeds is that BB doing? How many speeds is that?
Who cares? That's not even analogous to what we're doing.
It's actually extremely analogous because the BB is doing one speed from the person in the cart, one person from in reference to the cart themselves, one person in reference to the ship, one person.
How many motions does it have? How many motions?
Yeah, but the BB itself doesn't change motion.
Exactly.
No, hold on. Its speed. No,
it doesn't want to hold on to your negligence.
Stop, dude. You guys are interrupting me, so stop.
Finish.
The speed.
How long does this take?
He's got 20 more seconds.
It doesn't have one speed. It has all those speeds. It has more speeds than that. And speed is in reference to some other frame. Whatever frame you're deciding is going to be how you describe the motion. And the same is true for Coriolis, or the ball that you said. It's the same. It's just the path is reference frame dependent. The speed
20 seconds is up. We got it.
All right, Rocky.
We got it. That doesn't change the path of the BB. That doesn't change the path of the BB. The actual path that the BB takes doesn't care where you are on a go-kart moving back and forth or a ship or an airplane. The path of that BB, once it leaves the barrel, goes on a certain path, doesn't deviate, doesn't change, doesn't accelerate different because of where someone is looking. It may appear to because you're at an angle or far off or whatever, but doesn't actually do it.
Right. Like an analogy I was just thinking, if you're at like a concert, a huge rock concert, you could be in like God mode. You could be above the whole concert and you're just seeing the whole thing. One reference frame, bunch of people, they're all dancing, people up on stage playing music. It's like there's one reference frame. It's the whole thing. Now, you could then take individual observations from everyone in the audience, and they're all going to have a slightly different experience, a slightly different sound waves are hitting their ears in different angles and different echoes and all kinds of things. But there's still the universal frame in which that whole thing is happening. So if there's a ball or a BB or whatever it is, that's the frame. Just because you have a bunch of other people viewing it from a bunch of different angles doesn't mean that those are that there's not a base reference frame by which all those other ones are rooted from.
Exactly. The concert still happens in the time that it takes, in the frame that it takes, and each click, if someone throws a ball, the ball goes in the same path. It doesn't change anything because of where someone is viewing it from.
How do we
let me
determine?
just be clear real quick. All right, go ahead, Jace. I'm next.
How do we determine which one is the base frame, which has more precedence over another? How can someone explain how we're making that determination?
I can explain it. Hold on, guys. I can explain it, Jace. Well, if your argument is we know how to throw a ball straight on Earth, then we're going to know that the other one is only apparently visually curving and it's actually going straight. But if your argument is we don't know if we're throwing a ball straight on Earth or not because there's no universal reference frame, I guess this argument will have no conclusion for you.
How does that explain it? What are the criteria for determining what's the base reference frame, which one has preference over another? That doesn't even make any sense. You're saying one person's viewpoint has preference over another person's viewpoint.
The opposite of what you're doing.
Things work.
Well, I would say okay, well, what really exists is the reference frame. Like the rock concert I was talking about, there's speakers, there's sound waves being sent out from the speakers. That's the actual frame in which the concert is happening. Just because somebody's on the left, on the right, up, down, wherever, hearing it in different angles, just because they're in their own reference frame, the reference frame in which all that is happening is the earth, the ether, the atmosphere, a million words you could use. It's reality, the actual thing that exists. So if it's a ball going through the air, it's a ball through the air is the reference frame. That's the base reference frame that everyone agrees is happening. The ball is going through the air. It's just different people viewing it from different angles.
Like I said, if you think we know how to throw a ball straight on Earth, then we know it's going straight. But if your argument is we don't know how to throw a ball straight on Earth, you're going to be fucking pretty confused right now.
Yeah.
Okay,
if you're sitting on third base, if you're sitting on, hang on, I'm going. If you're sitting on third baseline and the pitcher throws a slider, you're not going to see it slide right to left. You're not going to see that happening. You're going to think it's a fastball. But it's not a fastball, it's a slider.
You're all just giving different kinds of reference frames, but you're not saying how you've determined what are the criteria that there's a base reference frame. Right, you're contradicting yourself. You're saying there's this base reference frame, but then there can be other reference frames. People can be moving and doing other frames, so there isn't a base reference frame.
Okay, so you don't. So it sounds like you're saying, I could be wrong. Just let me get it clear. I think we know how to throw a ball straight.
No, I didn't say that, Jeremy.
From the Earth reference frame.
I know you didn't say that outright. Hold on, I know you didn't say that outright. That's why I'm asking, because what you're saying is heavily implying that. So do we know how to throw a ball in a straight line on Earth?
Yeah, sure.
Oh, yeah, sure. Did you say yeah, sure? Yes, sir.
I said, yeah, sure.
Oh, okay. So we do know how to throw a ball in a straight line. So that means when the guy gets on the roundabout and sees it apparently curving, we know that's not actually happening. It's just a visual effect. and it's actually going in a straight line, right?
But how do you know that? To him, that is actually happening. So how are you what is the criteria for you to say that his view isn't what actually is happening, but my view is what's
You're
actually
asking what a
happening?
straight line is?
Hold on, because you already agreed. Hold on, man. Hold on. I'll stop talking after this. Because you just agreed that we do know how to throw a ball in a straight line on Earth. That's my criteria.
For me as a pitcher throwing to a catcher, me and him are stationary relative to the Earth. We can agree on what a straight line is for us. But someone else moving, they may not see it in a straight line. They're not going to agree with us that that was a straight line for them. What is the criteria for saying that me and the catcher's reference frame takes precedence over someone else who's moving and doesn't see it that way?
Because we do know how to throw a ball in a straight line on Earth, right?
Dude, you're just asking the same question that I've answered already. Yes, to me and the catcher standing stationary relative to the Earth, yes, we will agree that we threw the ball on a straight line.
We do know how to throw a ball in a straight line, so when that guy sees it spinning, we'll know that's just a visual thing. It's not actually rotating because we know how to throw a ball in a straight line on Earth, right?
But it's not a visual thing to him. He can take measurements of the location, the 3-coordinate location in space of the ball's path, and it's a curve. It's not just a visual thing.
Jace, you said it's not just a visual thing for him, but we know how to throw a ball in a straight line on Earth. You agreed to this. So we know it's a visual thing for him. If he says it's curving, but we know we threw a straight line path, we know it's just visual for him because we know how to throw a ball in a straight line.
No, what I'm trying to elucidate that nobody can give me the criteria for how we're saying that the frame with me and the catcher stationary relative to the Earth takes precedent over the frame with the person moving, even though we can take all the same measurements and we get different results. So what distinguishes them as ours is the true frame and his is just a visual thing?
Yeah, I'm going to back off. It's just gotten stupid at this point. Go ahead.
Yeah, just going around in circles. I'll tell him. I'll answer to him. Very simple. Reality. I know I throw the ball between me and you in a straight line. There's no disputing that. So anybody else viewing it, that's on them. They might be viewing it zigzag if they're going up and down. They might be viewing it in a circular path if they're curving. That's not the issue.
But SC, they're going to tell you, they have the same argument. I saw the ball move in a curved path.
No, they don't have the same argument.
They saw it. They didn't catch it. They didn't throw it and catch it in a straight line.
It doesn't matter if they're participating in the action.
Yes, it does matter.
Ridiculous.
Yes, it does. You answered your own question. Yes, it does.
No,
that's reality. No, stop talking.
Dude,
stop talking.
Talking me.
No, I started talking.
You're also
I'm tap muting both you guys. Hold on.
Hold on. Well, no, you don't have to mute anyone. Just go one at a time or something.
Yeah, I was talking. No, I was talking. How do you have something to say?
Just go one at a time. Jace,
I'll go. I'm trying to explain where he's wrong, and he's just trying to repeat what he said already.
Right. Just say your point, Rakia, and then Jace, you're
Thank you very much. The point is, the ball does go in a straight line. It does appear to curve to other people. You're agreeing with that. You're already saying what your answer is. The ball is being thrown and caught. So this is not you interrupting right now. The ball is being thrown and caught from the pitcher and catcher. Oh my God. I'll start again. The ball is being thrown and caught in a straight path from the pitcher and catcher.
The pitcher and catcher
People
see the ball.
are viewing it, moving, walking. You're interrupting again, asshole.
Stop screaming. Stop interrupting.
Why are you so mad?
Hold on. Man? Yeah, Rakia, you did make a very long pause. You also may have a delay. Let's just let Jay. I think you said your point. Let's let Jace respond. Go ahead, Jace.
Yeah, the pitcher and catcher are also visualizing the path of the ball too, just the same way that the people moving are visualizing the path of the ball. So there's still no distinction here. Like, you're not making any kind of distinction. They're still looking at the ball moving just like the person who's moving is looking at the ball. There isn't a difference.
I hear you. Oh, let me jump in. I hear you on that. But what I would say, that's why I said the idea of, God mode, like in a video game when you can, you do a code or whatever, and then you can float all around. You can see the character in all angles, that idea of like God mode, you can walk through walls and all that. So I'm just using that example. So if you got we're using the baseball pitcher thing. So you got a guy, you got a bunch of guys on a baseball field and you got a pitcher. The pitcher is going to throw a straight ball. In reality, it's going to be a straight ball, meaning compared to the air. See, this is where it gets into the globe thing because they try to say everything's relative. There's no verticals, there's no horizontal. It's all relative to the center of a sphere. That's where it gets all wonky. And I get why you guys are trying to defend that absolutely pseudo-physical conceptual bizarreness to support this globe model. But in reality, in the actual world, there is horizontal, there's vertical, there is actual geometry. There's the XYZ axis of reality. So if you have an actual XYZ axis, when the pitcher throws the ball, compared to vertical, compared to horizontal, etc., compared to that XYZ, the ball is actually doing a thing. It's actually traveling. Now, if you were in God mode and you could see it from above, you would see the ball going straight. Just because you have different angles of people seeing it from different angles doesn't mean that the ball isn't going straight. But I understand where you're going because but the relativity thing, you're trying to make that there isn't a relative frame, trying to erupt all of physics and just destroy that to try to, I'm not saying you're weaseling, but the people who have invented the globe model have tried to weasel in this relative situation so that they can make a ball floating in space even though it's a theoretical concept and try to say that that's reality. They're trying to replace reality with a whole fabricated geometry.
Okay, well, that was a lot of obfuscation. I heard one thing that might be criteria, that there's an XYZ axis, but the issue is there's an XYZ axis for the person who's moving and viewing what's going on as well, and they get a different path than the two people who are watching it that are stationary on the field. So how are we distinguishing between which one of those is the true frame? I'm still not hearing a way to discount one frame and distinguish the other one.
All right, well, hold on, Jared. If you want the next, hold on. Well, let me just respond because he tried to say I was obfuscating. I reject that. I don't think I was obfuscating. I might have gone on a little bit of a rant in that when I went a little long-winded, but I did answer it because I was saying that the universal reference frame is vertical, horizontal. There's an XYZ. That's what, and I was also referring to the sort of the God mode, the idea of zooming out. So that's how I was describing it. But yeah, go ahead, Jeremy.
No,
but the XYZ is. Go ahead, Jeremy.
We know how we can tell, right? Because you said we know how to throw a ball in a straight line. So we know that ball is going in a straight line. So when the person gets on the roundabout and sees it curving, we're like, nuh-uh, we know how to throw a ball in a straight line, right?
Yeah, it's like I was thinking of I was thinking of the Doppler effect. When you hear a car go by and it goes, and it changes pitch. Well, the actual engine is not changing pitch. The universal reference frame, if you were in God mode, the engine is staying at the same RPM or whatever, but it sounds like it's going, making a louder or a higher and lower pitch. But that's due to the Doppler effect. That's due to you're observing it and you're hearing a different pitch. But the actual engine is not putting off a different pitch. The engine, if you want to call that the universal reference frame, it's just pinging at 5,000 RPM in this scenario. Let's just say you just have it stuck at 5,000. But as the car goes by, you're going to hear it change pitch. It's not actually changing pitch. It's that you are hearing it from a different reference frame. But the universal reference frame is reality, what it's actually doing, which is the pitch it's actually at.
But what happens if the car is moving and I'm stationary? Then which is the universal reference frame there?
And dude, you're making it too complicated, bro. We got a guy throwing a ball in a straight line. We know how to throw a ball in a straight line. We all agreed on that.
So
we all fucking agreed on this.
Hold on, Jeremy. You keep asking the question, can we throw it on Earth? Can we throw a ball in a straight line? But
we've already all agreed to that.
Hold on. But I'm going to add some fuel to this dumpster fire here. And I'm going to ask you, can we throw a ball in a straight line if it's viewed on Earth? Maybe we're viewing it from the moon or from Mars or from just floating in space. Why is that ball in a straight line on Earth viewed different from a different reference frame outside of the Earth?
Because all of those things you just said are made up, with all due respect. You fabricated the idea of outer space and being somewhere other than the Earth. The Earth is the only thing any of us have ever witnessed, observed, tested. Any physics that has ever existed in the history of humanity has been right here on Earth.
Yeah, it doesn't. I don't even know what he said. But if you go ahead, Gio.
Well, I was done. I think Extremis is.
That.
Go ahead.
Yeah, he said you're lying. He said you're lying.
Lying or denial, take your pick. But either way, my point stands.
Okay, where have your physics
shows?
Yeah, go ahead and show me what.
Yeah,
if you're gonna go to the extent of call me a liar, show me what I just said. I laid out physics test not on Earth.
Physics test not on Earth. How about?
Yeah, show us your video from Mars of a ball.
Well, that wasn't technically.
That was your example.
I was actually going to use.
That was your
example. I was going to use a test from. How about the Parker Solar Probe? That's actually a physics test from outside of the Earth. Oh, or they have the Gravity B test. Those are actually outside of the Earth too. The Gravity B probe, again, gravity. I realize that's a curse word here, but still.
It's not replicate. You can't replicate it. We can't go verify it. We just have to take the word that it happened. This is all off the rails now. You brought us way off the rails. We know how to throw a ball straight on Earth. We know when the person gets on the merry-go-round that they're seeing it apparently. Am I robot or is it Rocky?
I got a delay, buddy. Sorry.
Well, I might have been in a bad spot. Go ahead.
No, I started talking way into your deal. Like it was delayed. Go ahead. I'm just saying, you and me can go out and replicate what we're talking about. They have to something from Mars or whatever. We all agree that you can throw a ball in a straight line, and when you view it moving or from a different perspective, that it appears to do something else. But that's not real. That's what it appears. That's how we're seeing it. That's not its actual path.
Yeah,
the pitcher and catcher are also seeing it, though. You're saying that their path that they see is somehow more absolute than the path that someone else sees, and that's where the hang-up is.
Well, I'm saying if you see the ball, hang on. Let me address him real quick. I'm saying if you see the ball curve because you're in a different reference frame, but you go stand in the way, you get your girlfriend to go stand in the way of that ball, although you see it curve, guess what it's going to do? It's going to hit her. I don't care how you see it, how you view it, how you say we can't give all the particulars, whatever. It's still going to hit her, dude.
Yeah, no one's saying it wouldn't, though. But what was being said before
that is that reality.
is that there's an absolute
let him respond. Rakia.
Well, that's what he's saying. There's an absolute frame because the ball would, if you put a person in between it, it's going to hit them. There's obviously a real thing in reality happening, which would be that's the absolute frame.
Yeah, but the person moving relative to that still sees the ball curve and hit the person. They're still seeing it curve, and they're still seeing it hit the person. Where the people on the field that are stationary in reference to the field and the ball and the earth, they see it just going straight. So we're not distinguishing between, they're seeing the same thing, but they're seeing it two different ways because they're in different frames, and we're not giving a criteria to distinguish between the claimed absolute frame and one that's of lesser importance.
Okay, cool. So you're saying we don't know how to actually throw a ball in a straight line on Earth because we're not sure if it's the guy who's turning is seeing it, if it's actually curving or if it's actually going straight. Saying we don't know how to throw a straight ball on Earth.
Yeah, ask the person who got hit if it came straight or if it curved.
Hey, Jace, can I?
You've already verified that we know it's going straight because you said we knew how to throw a ball in a straight line on Earth. Now it feels like you're arguing that we don't know. We're not sure. How can we be sure? There's no absolute reference frame. We don't know if we're throwing a ball in a straight line on Earth anymore.
I never said
it feels
any
like
of
you're
that.
double speaking your ass off.
No, I said if I'm a pitcher and there's a catcher, I can throw the ball straight to him because we both agree in our frame that the ball just traveled straight. But someone else we're watching the path of the ball as well. Someone else can be moving and watch the path of that ball. The ball still leaves my hand. It still is caught by the catcher, but the path they see is curved. How are we saying one of those frames is more important than the other?
Because what is it actually? Well, what is it actually doing? Because you just said you throwing the ball straight, it's going straight. If the actual ball is, see, this is why I was saying there is an actual vertical and horizontal in reality. That's the thing that I don't like. That maybe you're not registering.
The person moving also has that vertical and horizontal as well, though. They're not excluded from that because they're moving.
But they don't have their own vertical and horizontal. Vertical and horizontal are universal.
Then how can they see different things? You agreed one of them sees a curved path. If they don't have their own vertical and horizontal, how can they see different things? They would have to see the same thing if they had the same horizontal and vertical. They would be in the same frame.
They're moving, or they're viewing it from some different angle.
Yeah, that gives them a different horizontal and vertical. They still have one. And it gets back to the same thing. How can we say the people on the field's vertical and horizontal is more important than the person who's moving vertical and horizontal?
Dude, sum up what you're saying. Are you saying the ball actually moves in a different path, or it goes in a reality? It goes in a straight path, and we just view it as something curved at different angles?
No, what I'm saying is
sum up
that it's
your
relative. It's relative to the observer.
Yeah, so we don't know if the ball.
Yeah, just the view of it, right?
We're saying we don't know. There's no absolute reference frame. We don't know if we're throwing the ball in a straight line or not, because how do we know? Because the person on the merry-go-round sees a curve. So we don't know how to throw a ball in a straight line on Earth, you're saying.
No, that's not what I said. Go ahead, Kosho.
Yeah, because
exactly what you're double speaking your ass off, because you are saying we know how to throw a ball in a straight line, but then you're saying there's no absolute reference frame. How can we know if the ball's going straight or not? You are a double.
Go ahead, Kosho.
Just don't get this, Jeremy.
I'm going to stop talking.
But I'm going to try this once more. So please allow me this question to maybe Gio, because he brought up the concert. But Gio, in that concert that you talked about, you spoke about God mode. I'm just going to use that term God mode as this universal reference frame or whatever. But in that concert, Gio, where's God mode? You said the ether or the earth or whatever, right?
Well, that would be, let's say, zoomed out. If you could leave your body, like an out-of-body experience, and you could see the whole thing from above. Yeah.
And everybody else there enjoying the concert, they're in their own reference frames because maybe they're moving and they're on a seesaw. Who knows what they're doing? But the correct one is that God mode. Okay. And so is this also true if this concert was taking place on a cruise ship? On the cruise ship that was moving, God mode would be outside the cruise ship. It wouldn't be like the person watching the concert, above everybody else.
Yeah, it would be. Yeah, it would be out above the cruise ship, and then if you're saying there's a concert on the cruise ship, so the ship's going 30 miles an hour, and then they're all going. Yeah.
Okay, so God mode is outside the ship. Okay, and back to the baseball on that same ship. If there was a speed, one of those speed pitch things, and it was horizontal in reference to the ship, so it was going from port to starboard, left to right or whatever, and people were competing to pitch, and there was people reporting it, and the reporters were all over the place. They were they're at the fucking dugout or whatever, the speed pitch place. They were on the ship somewhere else. Some of them were in helicopters watching it. Some of them were fucking on the shore watching it. Okay. And they're all tasked to report what the path of the pitch and also the speed of the pitch, right? They're all separately supposed to report this. Is there any one of theirs reportings that's going to be more correct than anybody else's? Or are they all going to have the same reporting? You understand what I'm asking?
Yeah. I'm not sure I was fully. I mean, that was.
It's all about speed.
Yeah,
skating around the fact that we don't know how to.
Hold on. You can answer it too, Jeremy, but it's just a speed pitch contest. There's different reporters. The different reporters are in different places, helicopter, boat, on the ship with them, on the shore. They're reporting the type of pitch, so the path of the ball, and also the speed. They're doing their own separate reports. Are their reports going to be identical, or is somebody's report going to be more correct than somebody else's?
Yeah, the report that's right next to the pitcher and the catcher is going to be the most correct. Reality.
Well,
the guy from the helicopter isn't going to know if it's curving or not.
Okay, but that disagrees with Gio's, his version of the absolute.
Not really. You're having God view, not moving with the ship. He's right there above the ship, viewing it.
Okay, but yeah, so there's
the same speed in the same direction. If he's viewing the pitch from the pitcher to the catcher, he's right above it in that direction, viewing it. That's God. He sees everything.
But he's moving with the ship.
That's what Gio was talking about. Obviously, yeah, he's in the best position to see reality.
Okay, well then that's not that same frame though. The frame outside the ship would be in reference to the ship moving. So the ship would be moving, and this God mode would be stationary in reference to that. So that's a different.
The ball still travels from the pitcher's hand to the catcher's in a straight line. It still goes the same speed, Kosho, no matter how many helicopters, people on the beach, naked girls in a parachuting over the.
You're trying to get
ship. It doesn't matter. The ball travels from the pitcher's hand to the catcher. Yeah, like a dude. So Kosho can relate better. This is how far you have to go, dude. A moving ship, helicopters, people on the beach, ball going horizontal and vertical, a speed gun measuring vertical speeds.
Yeah,
come on, man.
This is what I said.
Yeah, you're letting them.
Hold on, because at this point now, I know it's not clear to you guys, or maybe it is to some of you guys, but you're disagreeing with each other, and that's because these are different reference frames. If there's the reference frame that's moving with the ship is a different reference frame than the ship is moving in reference to.
So okay, but the ball still travels at the same speed in the same direction, right, Kosho? Then no matter where it's viewed from, the ball still goes from A to B. And if it's thrown in a straight line, that line doesn't curve ever, right, Kosho?
No.
It just appears to.
Well, no, that's what I'm saying.
It just appears to, right?
The observer is only able to.
But that's what you're saying. It just appears to.
Hold on. Hold on, Kosho. Hold on. Are you done, Rocky? Are you done?
Well, that's the main question, Kosho.
Sure you're done, so he can go. I know.
That's the main question, Kosho. Pay attention. The ball that travels in a straight line, no matter who's doing what, if someone views it doing something differently than going in a straight line, it just appears to curve or do whatever, or slow down, or go faster, or go up or down, or whatever. It just appears to do that, right, Kosho?
Yeah, it appears to do it.
Okay.
Good. Thank you.
No, that's not okay. Jeremy's trying to interrupt me in the middle of me.
I'm trying to make sure you're done.
Well, then, okay. Well, regardless, done. I'm saying okay, as in you're finally done. But yeah, it's I forget the question. All right. It's appearing to do this because it is doing this. From all those frames, they're correct. Everybody's observation of the speed and everyone's observation of the path is correct. Now,
the ball isn't actually.
Hold on, man. Yo, he ain't done. He definitely ain't done.
Hold on. Yeah. So the one that is moving with the ship, the ones that's on the ship with the pitcher, theirs is going to be the most relevant one. The one that's probably the most, it's relevant to the actual event that's happening.
Realistic. Yeah.
No, it's not realistic. It's not realistic because, like I said, in reference to what Gio said, the most correct one is the one outside of the ship. The one that's not moving with the ship. And so he would observe a different speed for that ball, a different path for the ball, and a different description of what it's doing. So the correct reference frame in this example is actually one that is not the God frame, as we're referring to it. And the actual moral to the story is there is no God frame. The reference frame that's always used is whichever one's relevant or whichever one it's observed from. But none of them are more valid or less valid than any other intrinsically.
Okay.
Well,
all right, you good? Rocky, go ahead.
The fact that except for the fact that if you throw a fastball at 90 miles an hour and it travels in a straight line from the pitcher's hand to the catcher, and then you report it as a curveball going 70 miles an hour because you viewed it from left field from a helicopter in your man bikini? Who's right or wrong there, Kosho? Yeah, that's what I thought.
I didn't get a chance to answer the question.
Answer would be fastball. Okay, the right answer, I'll answer it because we don't really need you in this case.
Rocky, you're roboting.
The right answer would be it was a fastball thrown from the pitcher's hand to the catcher's mitt.
At this point, you're agreeing with me, and I'll have to ask the first question again, which is the most important question, which is which frame out of all these frames we've talked about is ultimately the universal frame, the frame that everything else is moving in reference to, the frame where things are actually happening in, and everything else is just apparent. Which frame is that?
Whatever frame, whatever frame, Jace, you know what frame it is? Whatever frame, Jace, we were in when Jace said we know how to throw a ball in a straight line on Earth. We're going to use that frame because we know how to throw a ball in a straight line on Earth. So that's going to be the frame we use.
Yeah, I mean, the way I would describe, the way I'm thinking about this, if you have like X, Y, Z, and you have coordinates within that, any coordinate has an X, a Y, and a Z correlation within that matrix. That is your universal reference frame, as it were, X, Y, Z, and the coordinates within that. So in this idea, if you have that and you throw a ball straight, you're throwing it with, X axis, no Y axis, and the Z would be the parabola. So let's say, the X axis is 0 because it's being thrown straight. The Y axis is 0 because it's not going left and right. It's a straight ball. The X axis is straight because it's a straight ball. The Y axis is going to have the arc to it, the curve. There's going to be a little bit of the parabolic arc to it. That's what's actually happening because there's a real vertical and a real horizontal in reality is what I'm claiming, what I'm saying. That means like up is up, down is down, horizontal is horizontal. That being the case, you have an actual X, Y, Z matrix, and then you have coordinates within that. So if the ball is doing that, like I said, no Y-axis, only the X and a little bit of, sorry, I said that wrong again. You know what I mean? But with the X, Y, Z, if that's what's actually happening, the ball being thrown straight, that's what we're talking about. Now, whether you have one observer or 50,000 observers doing it from all different angles and they're spinning on merry-go-rounds and whatever they're doing, that's all. You can talk about those individual ways that those people view it, but in actual reality, compared to vertical and horizontal and compared to the X, Y, Z, that's what that's what's actually happening. That's what it's actually.
Yeah, your response is no offense to anybody else, but your response is consistent, and I totally understand where you're coming from. Because like I said, the idea of the ether back in Mickelson Morley time was this same idea that there was a universal frame. It wasn't the Earth, obviously, but it was the universal frame outside of the Earth that everything's moving in reference to, and that's a fair assumption. Of course, you're using the Earth as this reference frame. Yeah, so it's like if I were to ask you that same question about the ball, you would say they would all have different descriptions, but based on your position, you could also say that they're all using the universal reference frame, which is the Earth reference frame. They're all using that reference frame to describe the movement, and so they all get the same answer.
Can I say something?
Go ahead, Bacon.
Right. So that description of a coordinate system is excellent. It pictures exactly what a reference frame is. So if the point in which those three axes that you mentioned meet is what we call the origin of the coordinate system. Right? So we can have, for example, in the merry-go-round, we can fix that coordinate system on the center of the merry-go-round in such a way that which one is your up axis, Gio? The Z one is up?
We use
vertical.
Right. Okay, so if we can fix the X and Y on the merry-go-round, and what happens there is if the merry-go-round starts spinning, the whole reference frame starts spinning. So if you throw a ball, the path of the ball in the reference frame that is rotating with the merry-go-round isn't going to be a straight path. So although the whole thing about a rotating frame is that if we rotate that reference frame around with the merry-go-round, the path of the ball in that frame is actually curved. But if you have a second reference frame, a second coordinate system, that instead of being fixed on the merry-go-round, it's now fixed on the ground, in that coordinate system, the path of the ball is straight. So you can have the same ball doing the same thing, but it creates a curved path in a rotating frame, and it creates a straight path in the other frame of reference. They're just coordinate systems.
Oh my God, yo, this is so fucking simple, guys. This isn't really hard. We know how to throw a ball in a straight line on Earth. The guy gets in a merry-go-round, he sees it fucking curving. We know it's not curving because we know how to throw a ball in a straight line. Right? How fucking simple is this?
I just don't think that they can agree. I mean, I had it nailed down. It just appears to, right, when you're on the merry-go-round. If you know the ball is thrown in a straight line and you see it any other way, it's just because that's how it appears to you. Okay, it doesn't make it wrong. It just makes it an apparent way the ball is flying. The ball actually, in reality, in actuality, can't change this fact, went in a straight line.
Right. And that's why I was saying it's straight compared to vertical and horizontal, which are actual universals. Like horizontal is horizontal. But this is kind of at the crux of the whole thing with the globe, because they've basically tried to make reference frames relative at the end of the day. And then they've tried to make space the universal frame, I guess, is kind of the closest they might say. And then now that this fabricated outer space thing, now the globe is just one reference frame amongst all these other reference frame, Mars and Pluto and Jupiter and all these other things that now create this like relative reference frame standard by which they then sort of convolute what vertical and horizontal are, because now vertical and horizontal are all just these relative reference frame compared to which planet you're on. So if you're on the moon or if you're on some other celestial body, vertical and horizontal are totally different than someone who's on Earth, and it's all relative to the center of the spheres or whatever. So it's like a relative reference frame inversion and deception that's kind of at the root of this whole inverted geometry.
Why do you think they have to fight for it so much? I mean, the last hour and a half has been fighting for an apparent position. They know the ball is going straight, but it looks like it's curving to someone else. They're fighting for that fact. Why? Like,
Do they know
does
it's
that
going
matter?
straight? Do they know it's going straight? There's no universal reference frame. They don't know if it's going straight. They'll tell you they know how it's going straight, but then they'll tell you in the next breath that there's no universal reference frame. How can you be sure it's going straight? They're double speaking their ass off.
No, it's because they're saying it's because they're saying it's only going straight from one reference frame because they're all relative. So that's what they're doing. So instead of saying there's one universal frame in which it actually is going straight because vertical is vertical, horizontal is horizontal, there's actual coordinates within reality. They're just basically making all of that relative and saying that it's only straight compared to one reference frame. And then another reference frame, it's something else. Like it's all relative in their.
So we're on Earth. We know the ball's going straight. They get on the merry-go-round and it starts to curve. We know it's going straight, but they only see it curving because they're on the merry-go-round. Otherwise, they'd see it going straight just like us. Why is this so hard?
It's not hard. Nobody disagrees with that. But
yes, they did, Coach.
No, they don't. They don't disagree with what he just said. No, they don't. Nobody disagrees.
They just agreed with it an hour ago.
They disagreed with you that it's those two different reference frames see those two different things. That's what they disagree with you. Is that what you're saying, Jeremy?
No, they're disagreeing that we know the ball's going straight. The other guy sees it curving. We haven't been arguing about that for the past hour just now.
Yeah, what you're saying is even though we know it's going straight, this person's going to see it doing this. That's what you're saying. And what you guys are neglecting to realize is that that's the first principle in physics, basically, was this principle of relativity. And it's just the way that all motion is described. It's either you're implying a reference frame or you describe the reference frame. But if you don't do that, or if you try to say that and no reference frames, this is how fast it's going, or this is how fast it's actually going, regardless of reference frames. Those statements don't make any sense in physics. They don't make any sense.
Well, then your physics doesn't work.
There has to be a defined or implied reference frame.
No, if relativity is what you're talking about, and that's known physics, that's what you're saying is reality. All goes in a straight path, and it appears to curve depending on your angle or whatever. That's reality. That's not relativity. You're talking about magic. The ball that we threw, that we made go in a straight line, we can measure it. You can measure it from a different angle, appearing to do something else. But in actual fact, in reality, things you can't change, or the ball did go in a straight line. You can measure it 1,000 different ways. Those measurements aren't right.
There's no universal reference frame. You don't know if the ball went in a straight line or not.
Yeah, you do, because you're not going to reference a universal reference frame. If somebody says, "Hey, did that ball go in a straight line?" and they don't define the reference frame, then the reference frame is going to be implied, or it's going to be assumed, right? You're not going to just think, "Oh, maybe they're talking about a universal reference frame." Like on the ship, for example, whenever I asked for Kia, he assumed the reference frame that it should be recorded from is the reference frame of the ship, and I would agree with him because that reference frame is the one where that makes sense. And that's always
you brought this ship thing in to confuse things.
No,
It's as simple as throwing a ball.
To show you how the reference frame is always it's going to be attached with the description of the motion. Otherwise, the description is not going to make sense.
Yeah, okay.
Depends on what you're asking about.
Shit. Yeah, when you start doing all kinds of goofy shit, yeah, you can explain it from all different kinds of ways. We're here stationary on Earth, and somebody throws a ball in a straight line. We know it went in a straight line. So when the person gets on the roundabout, we know that it's not actually curving for them. It's actually going in a straight line. We know if they step off, they will see what it's actually doing, which would be going in a straight line.
What is the path that it takes in a rotating frame?
Optically, it takes a curved path, but that's not. It's not actually curving. It's actually going straight.
I didn't ask optically. What's the path that it takes in the rotating frame?
Well, do you want to put a ruler up to it and we can see?
Was it thrown straight?
Rocky, you're roboting.
Yeah.
Cover it in ink and roll it.
Let's say I draw on the floor of the merry-go-round a grid. I draw a grid on the floor of the merry-go-round. So now I have a physical representation of the merry-go-round reference frame. So I can take notes.
Better yet. Hold on. Better yet, Bacon. I set up a board in the air right next to the where the path of the ball. I put yardsticks all along that path so we can see which path it took. How's that sound?
This is so many analogies. I don't even know if I can even remember all of these, all the levels of things I'm having to imagine as you guys are adding all these things. Fair analogies.
We can see which way it went. We don't have to trace the line on the floor of the thing that's rotating. We can just I can put some yardsticks up. We'll put some stakes in the ground, put some boards up, 2x4s or something, and then I'll throw the ball directly across the 2x4s. They're going in a straight line. Now what's up?
You just put those boards up in the reference frame. So yeah, we can determine
the boards. So the boards we can clearly see.
We'll determine what it's doing in that reference frame.
We can clearly see that no matter which frame you're in, you're going to see the boards. Are the boards going to be curving because you're in the rotating reference frame?
If you're recording them using the boards, then the reference frame that you're recording the motion in is going to be the same reference frame that the boards are stationary in.
Bro, I put boards up. I got 2x4s going in a straight line, and I'm going to throw the ball right along the straight line of the 2x4s. Right? Does the guy in the merry-go-round, does he see the 2x4s? Are they curving to him or are they straight?
The 2x4s are not in the merry-go-round. Is that right? If they're not in the merry-go-round,
2x4s are staked into the ground. I put fucking concrete posts down. Put 2x4s in it.
Then that's all curving to him, and his his frame, everything outside of his frame that's stationary outside the frame is actually curving to him because his whole frame is rotating.
Okay, so he sees the boards curving. Cool. But we know the boards aren't actually curving, right? We know they're straight. We picked them out at Home Depot They had a couple straight ones left, and we took those, and we know they're straight. We can measure them being straight, right?
Sure, yeah.
Yeah, so we know the ball's going in a straight line. It's not curving. It's only curving because they're in this goofy merry-go-round thing, spinning around like idiots, right?
No, like I said, if you're in the frame, if you're on the frame, the rotating frame, you're using boards that are not on the frame to make your record of what's happening to the ball, then even though you're on the rotating frame, you're not recording the movement from the reference to that frame. You're referencing the frame that the boards are in. So
That's why it's important to say that, like, you don't enter or leave reference frame. You're in both reference frame. You can use on the reference frame even if you're not there.
Hey, this is where I stop.
This is where all see. That's
Even
why
the rumpus.
Go ahead.
Go ahead, Gio. No, this is where I stopped because they said even Rumpus told these guys when you start talking like that about reference frames, everything's in every reference frames. Everything's in every reference frames. It makes it pointless to even say the word reference frame at that point.
No,
No, it
it makes
doesn't.
you gotta
Rumpus
make
told you that, Coach.
you
So
got to
you
make
know
a
that.
distinction. Yeah, no, and I told him, and he agreed with me that you have to make a distinction between an observer and the object that you're talking about. The object can be described from any reference frame. The observer is reference frame specific. It's going to be.
Will there be deviation if the thing doesn't go into the other reference frame? If the thing doesn't go into the inertial reference frame, will there be the Coriolis effect?
This is what I'm saying to you, dude. That question, just disregarded what I just said because I just told you every object is going to be in all reference frames.
It's
So
pointless to use reference frames at that.
No.
I mean, that's where I back out because now it's pointless to even talk about reference frames.
You didn't even hear what I said, dude. Dude, the object can be in all reference frames. That doesn't violate anything. It's the observer that's reference frame dependent. So the observer, you're going to describe it from a specific reference frame, but the reference frame you choose is up to you because that ball can be described from any reference frame.
I'm good.
Yeah, I mean, it all boils down to that they don't think vertical and horizontal are universals.
Oh,
Like
but even
like Bacon or Kosho, is horizontal a universal thing?
Even in a world where the Earth was stationary and flat, and vertical was the same for everybody, and so was horizontal, these rules would still apply.
Well, no, because you have a base reference frame.
No,
you have a universal frame of vertical and horizontal X, Y, Z, in which everything else is functioning within. So if you have that universal X, Y, Z, that's what we could call reality or the foundation, whatever. So whether the ball is traveling, that's what I was saying before. Like if you have no y-axis because it's going straight, the x-axis is also straight, and then the z has a little bit of parabola to it if you're throwing a straight ball. That's what that would be like the universal frame. Like that's reality. It's the foundation. Now, if you then have a bunch of other frames, a bunch of people watching it from other angles, those are all just secondary to the foundational one.
Why? But where is the origin of the foundational one? Where all those three axes meet? I mean, there's no obvious place where they meet. People have to establish where's the origin of that coordinate system, right? If they want to assign coordinates based on that grid system that you just described, they have to grid upon where
arbitrary. You can start anywhere. It's arbitrary. You start at your
Exactly.
house, in your living room, whatever. It doesn't
Exactly.
matter.
So if people that don't know each other establish in different positions, in different places, they're going to end up with different positions for the same things. So that reference frame is not actually the only thing that is going to be universal. There is the vertical. That's the only thing that's going to be observed universal.
The universal thing is going to be the ball's going in a straight line, like we already all know it is. That's the universal thing.
Yeah, but the reason you're calling it a straight line is because you have some coordinates to make it straight, which is what I'm talking about, a universal X, Y, and Z. That's the reason anyone's even able to say, oh, that's a straight line, is because you're comparing it to those three axes, vertical and horizontal.
Exactly. So
and the distance.
If you fix coordinates on the roundabout, now on that coordinate system that you fixed on the roundabout, when you throw a ball and you take notes of the coordinates of the ball when it's in the air, in that reference frame of the roundabout, if you use that reference frame, the coordinates of the ball is going to make a curved path in the reference frame, right? So it's not wrong to say that the ball is making a curved path in the reference frame. You can say, well, it's just it, but that's not the universal reference frame. I'd agree to that.
Yeah, well, that's why Well, that's why I use the Doppler analogy. So, like, let's say someone's in a car going down the street and they're playing a saxophone and they're playing a C note, you know, the note of C, and they're just blaring C. In reality of the world, they are playing a C note. Like, that's actually what's happening. That's, you know, but if the car drives by you, you might hear it be a C, D, E, F. You know what I mean? You might hear it tone shift. Now, those tones are still real for you. Maybe this analogy is not quite, because it's not the same.
Not good. Yeah, you seeing where it messes up. Yeah.
Well, it's just, this is a little different because you're actually hearing a different sound.
Well, no, but the way it messes up, because the person who's playing the violin or whatever, they could be on the craft that's moving. And so if the universal frame is the one that's, you know, the stationary Earth, they're actually playing a C note on their craft by themselves moving. No one's going to hear that, though, because everybody else, they're moving in reference to everybody else, right? So, you know, even though the note they're playing is C, nobody on the real frame and the God frame is going to experience that.
So we don't know how to throw a ball in a straight line on Earth, you're telling me?
What does that even mean? I don't
think anyone said that, Jeremy. Nobody said they can't throw a straight line.
You know how he is, man. He fixes on one thing. He sees a shiny thing and he just looks at it all day.
Okay, so we know the ball's actually going in a straight line. So then when we get on a roundabout, we know that it's not really curving because we already know it's actually going in a straight line, right?
Oh, it's clear to me that you're just saying actually
arguing against this. I thought they were arguing against this earlier with me, Gio. For some reason, Jace was not complying.
They are only in the sense that they're claiming that reference frames are relative. So they would say it's only moving straight in the first thing you said, we know how to throw a straight ball. They're calling that a reference frame. They're not saying it's a universal one. It sounds like the way you're implying it is that it's universal. So we all know it's going straight, meaning that's a universal thing. What they're saying in general is the only people that really know it's going in a straight line are the ones in the reference frame who threw the ball straight. Outside of that frame, all bets are off. From all these other frames, it's all,
Yeah. So when the guy gets on the roundabout, we're not sure it actually be curving, even though we can get the straight boards, put them up along the path. They're saying we're not sure because on this merry-go-round now and started spinning around.
I'm not even saying they're not sure. I'm saying that it's not. It's not doing.
Hold on, Gio. You're giving them a free ride, irregardless of that. It doesn't matter. The ball is still traveling in a straight line. They could be seeing it from a million different locations, saying they're seeing it in different motions. It doesn't change the fact that the ball is still traveling in a straight line.
To who?
Yeah,
anyone that can figure out that
it doesn't matter to no, that's not a question. It doesn't matter. To everybody that knows reality, that ball is traveling in a straight line. It may appear to be traveling differently. You can tap dance around that all day long. You can't change the fact that that ball is traveling in a straight line.
Yeah,
in reality, that ball is traveling in a straight line. Doesn't ever change. Regardless of the observation, that ball is traveling in. You're not going to let me finish, right?
You said the same thing 8 times.
Because you're just repeating yourself, dude. Just wrap it up.
Yeah, the ball is traveling in a straight line, period. End of story.
I was going to throw in I'm not trying to take into another topic, but I was thinking how, like, in the idea that there is a creator, even for atheists, like, even if someone believes there's not one, there still is one.
Okay.
Yeah, the only thing they have is a reference frame. The only thing they're trying to confuse here is that people looking at it from different observations observe it differently. That doesn't matter.
Okay, hold on a second. I know, Bacon. I know you're going to say something, Bacon, and I'm not going to go off with this. I'm really going to leave after this, Bacon, so I'm going to let you go on with this. I just want to say to SE, and your freaking idea, SE, on my cruise ship, there's no pitcher pitching the ball. There's just a fucking gun, a baseball gun, and it's horizontal in reference to the ship, sideways, and nobody's even there. No one's even on the fucking ship. Someone's steering it. Anyways, everyone's everywhere else. Okay? So who in the world is that ball going straight in reference to?
That ball is going straight when it comes out of that cannon, in that ship, whatever. It could be moving in a billion different directions. When it comes out of that cannon, that ball is traveling in a straight line.
Well, it gets a little more complicated because if you're on a moving ship like that and then you shoot it straight, or you think, okay, if you have a machine that shoots straight balls, like one of those pitching machines, if you have it on a stationary surface, it'll shoot it straight. But if you put it on a boat that's going 50 miles an hour and then you shoot it, the same shoot, it's actually not going straight because you're on a moving object that is, the ball's not going to be actually moving straight at that point. It's going to be because you're moving when it's launched out of the device.
No, it's still traveling in a straight line when you throw it, when you leave it. Even if it's on a rotating object, just like on the merry-go-round, when you release that ball travels in a straight line in the vector that it's released from your hand. Even the ballers will agree to that. Am I wrong?
Yo, he
ballers?
put you on a cruise ship to try to confuse it like we don't.
Of course, they're going to put you, yeah.
Shit, dude, I stole that from Bacon for a second. He left because of that, man. Thanks a lot,
Yeah.
SC.
Because you fucking try to complicate things, and I told Bacon that you make shit more complicated than it needs to be, and he's probably done with your goofy ass.
Look, there's nothing that they can say to change the fact that it's a visual effect. It's a visual effect. The ball.
That's literally, that is literally how half of the Globers at Gems, Bob, they all described it as an optical illusion.
Yeah.
It's just an optical, like that my scenario where the guys are throwing a ball back and forth in a straight line and a kid gets on a roundabout in the middle of it and sees it appears to deviate. They say that's just an optical illusion. That's verbatim how Bob described it.
Jeremy, you forget that all those dudes at Gems disagreed with us, and then I went and explained it to them, and then most of them
still don't believe. I went there after that months later, and had Rocket explain to them that they get a non-zero Coriolis value, and they still don't fucking believe it. You want to go there right now? And we'll see who thinks this is Coriolis or not.
I don't know why you guys keep talking about Gems. That's really irrelevant.
Yeah,
because they're the experts.
That is true.
Because half of those guys agree with us. Half of the Globers agree with us that it's just an optical illusion.
I don't know
Even
why
Zanuck knows it.
Nobody has mentioned Gems on this server in months, but for some reason last night, everybody, like, there were people in here that were like, there was some, I guess they were like, people said they were talking about, like, Witsit was over here talking, and they were apparently trying to like start some dramas. And I'm just saying, nobody ever mentions Gems here. It's kind of funny. Last night they were all like talking, they were trying to create some dramas with some sock accounts to trigger Witsit, and then now you guys are talking about them. I don't see the relevancy.
I was just pointing out that half the Globers agree with me and SC that this is just a visual thing. You heard Bob that one night.
It's nonsense.
You heard Bob that one night tell us it's just an optical illusion. My scenario with the guys in the park.
It's the double speaking. That's the beauty of it. It's the double speaking. You tell them, is it going straight? Yes. You know what Zanuck told me? Zanuck told me that the ball, check this out, guys. And if Zanuck is here, that's one thing I like about him. He'll say it. Ask him. He says that the ball both travels in a straight line and curving at the same time. Actually does it. Not a visual effect. Actually does it.
Yeah, in different frames.
You see? There's another one.
It's just like, can something go away and towards you at the same time?
So you're saying that the ball actually goes straight for one observer, and in the other reference frame, it's actually curving.
Yeah, it's actually curving the reference frame. If you assume the actual means in the inertial frame, then you are in a contradiction by the way you're using the word actual, which is not the way I use the word actual.
Oh,
it's actually the other. I'd say it's actually the other reference frame is curving, not the ball. It's the reference frame which is curving.
Yeah, but
we all know that, of course. Yeah.
If you take notes of the position of the ball in that reference frame, you don't get a sequence of points that make a straight line in that reference frame.
So the ball is actually curving. You agree with Zanuck?
In the rotating frame, yeah.
So the ball at the same time, let's get this straight now. We have two reference frame, and one, the ball is traveling straight, and at the same time, in the other rotating reference frame, the ball is actually curving.
Yeah.
Yo, real quick.
You heard it,
so,
guys. You heard it.
So can we tell are 2x4s being straight? Is that reference frame dependent?
What's 2x4s?
Yeah, because at the end of the day, that like the XYZ thing I was talking about, they have a different XYZ for every assumed reference frame. That's why this is different. So they're saying
that's what they are.
My XYZ is different than that one, and you're saying there is no universal XYZ.
Let me try this out.
I wouldn't even say that there is no universal one.
Can we tell? Oh, go ahead, Bacon. Let me go next, please.
Okay, so even if there is a universal, we can't see it, so we have to establish the ones that is more useful to use because we can't see a universal one.
Okay,
I'm
cool.
not even opposed to a possibility of a universal one.
All right, cool.
Ahead.
So can we tell if a 2x4 is straight or is that reference frame dependent? A 2x4 is a piece of wood.
Okay.
Can we tell if a piece of wood is straight or is that reference frame dependent?
No, I don't think the shape of the object is reference frame dependent.
So we can tell if a 2x4 is straight regardless, right? We know if a piece of wood is straight or not?
Yeah.
Yeah. Okay, so I can put a piece of wood up, stake it in the ground, throw a ball in a straight line, and it goes right. It doesn't deviate at all from the 2x4. And we'll know that the ball went in a straight line because we know the 2x4s are in a straight line, and we can measure that the ball stayed right with the 2x4s, right?
No, in the rotating frame, the 2x4 is rotating, right? So the ball follows along with the 2x4 in that frame, and that frame sees the 2x4 rotating. Then the path of the ball is still curved.
Yeah, but we know the path of the ball is actually going straight because we know how to actually make 2x4s straight, right?
No, because the 2x4 is rotating that reference frame. So the ball following the 2x4 doesn't mean it's making a straight path if the 2x4 is rotating.
The 2x4 is staked in the ground.
Yeah, but if you're rotating relative to the ground, you're going to see the 2x4 rotating.
Dude, this is
okay,
almost
great, but we know that.
This is almost to the point of like somebody has like glasses on that make things all warped, and the one dude's like, "No, man, that's a straight ball," and the other guy's like, "Oh no, it looks like a bent, warped thing." And then basically what they're saying is like, for the dude with the bent, warped glasses, it really is bent and warped because reference frames are all just relative and all independent from each other.
I'm not sure if that's very analogous.
Maybe
the glasses just creating distortions. Like I wouldn't say Coriolis is a visual thing.
Well, we know the 2x4s are straight, and we know the ball is going straight with the 2x4s because we can measure that the ball doesn't deviate at all from the 2x4s. So we know that, right? The 2x4s are straight, and the ball's going straight with the 2x4s, right?
No, that's
we don't know.
Okay,
hold on. We don't know the 2x4s are straight.
They are.
Okay, so we know the 2x4s are straight.
Yeah.
Okay, we plant them in the ground. We've got them posted in the ground. We got a straight line of 2x4s horizontal. They're not moving. They're planted in the ground. They're going straight, right?
Okay, are we planting on the ground too, or just a 2x4?
We're standing on the ground next to the 2x4s. I put posts in the ground. There's a straight line of 2x4s going horizontally.
All right.
Do we know that the 2x4s are straight? Can we verify that they're straight?
Sure. Yeah. I always yes to that.
Cool bet. We throw the ball. It doesn't deviate from the 2x4. It stays right the same distance away from the 2x4, goes in a straight line. So now we know the ball went in a straight line, right?
Yeah, in our frame you did.
The ball actually went in a straight line because we know the 2x4s are actually straight, right?
Yeah, but it's still actually in your frame.
No, not actually in my frame. In any frame, the 2x4s are straight, right? Because we know how to make 2x4s straight.
Yeah, but that doesn't imply that the ball is falling straight because in other frames. I'm good. You're gonna leave right when I justify my claim that you disagree with?
Yeah,
that's what I was just telling you.
All night.
That's what I was just telling you, Jeremy. It's the thing with the glasses is actually kind of correct. Like they're saying, if this other dude is on a roundabout with glasses that make everything warped, then it really is warped. It's basically what they're saying. It's not straight anymore when you're in another reference frame.
Okay, let me Like if let me give an example. So we're in a merry-go-round, and there's a 2x4 there in the merry-go-round rotating with it, and I put a toy car in the 2x4 and make the car go straight relative to the 2x4. So the toy car isn't deviating left to right in the 2x4. It's going from one end to the other end while the whole thing is rotating. If I'm not in the merry-go-round, to me the path of that car is curved, even though it followed along the path of something that is I know to be straight, because that thing is rotating. I can see the car making a curved path. So saying that the car is following the straight object doesn't imply the path is going to be straight, because that object might be rotating. So when
yeah,
you
but it
put
either is or it isn't, Bacon. Like,
sorry,
it either is or it isn't. There's an objective answer which you guys just want to ignore.
Okay, so is the toy car going straight or not?
Yeah, it's objectively going straight.
No, you didn't get the experiment then.
Okay, well,
The 2x4.
Just pretend he's envisioning this all in his mind, making it up like a dinosaur.
No,
You'll
this
get it.
isn't the thing I just mentioned. Isn't even related to Coriolis. Well, one sec. You're not in the merry-go-round. You're outside of the merry-go-round. There's a 2x4 connecting both ends of the merry-go-round, going right through the middle, and the roundabout is rotating. Right. The toy car goes from one end to the 2x4 to the other end of the 2x4, while the merry-go-round is rotating. You're watching that outside of the merry-go-round. What is the path that the toy car does? Is it a straight path or is it a curved path?
It's traveling in a straight path. It just looks curved to you. But there's an objective truth that it's going straight.
But it's only going straight in a rotating frame this time. Not in the universal one that you guys call the actual one. In the actual one that you guys call the actual one, it's now going curved.
What do you mean?
Because the
You
2x4 is
you're
rotating.
delusional, right? Do you realize that, right?
You're just not picturing. Okay, I have to draw it.
I know what you're
Bro,
saying.
there's nothing you can say that can change the actual path of an object.
Dude, you should be.
Do you
I'm
not
not changing the
understand that?
actual one. I just described an actual curved path that, under your guys' definition of actual, should be
No, it's
curved.
only in your brain.
No, I think you
There's
still don't
nothing
get
that
it.
you can do that can deviate a path of an object. Actually, it's all visual. That ball is traveling straight. It's all in your mind. The rest is
There's
all in
no
your mind.
ball in this example. I'm pretty sure didn't listen to the example, because if you did, you wouldn't be saying that.
Yeah,
There's no example that you can make on this universe that could change the deviation of
That
a
is not
ball.
changing the path. The path is established curved. You're not getting the example.
Not curved. It's a straight
I
path.
just described the curved path. You just didn't pay
No, in
attention
your
on the
mind, in
example.
your brain, you
Oh my
described
god.
it.
Okay,
No,
I'll
the
draw
path
it. I'll
did
draw
not
it.
change. Negative.
I'm pretty sure
If you had a
guys
computer
can
chip in the
will understand this if you can check the drawing. We just draw it.
No, logical people will understand this. What you say makes no sense. I want to make that clear.
Okay, tell me
No sense at all.
Tell me what my scenario was. I'm pretty sure it didn't follow it.
Your scenario is, to the observer, the ball is actually curving.
There's
Very
no ball
simple.
in my scenario.
Lunatic
There's not even a ball.
nonsense.
I didn't even mention the ball, dude. You're not listening. You're answering to a scenario that was described before my scenario. You guys are clearly not listening to what I'm describing now.
Is the ball
You
deviating,
said
yes or
you're
no?
outside on the ground watching a merry-go-round. There's 2x4 going from one end to the other. I'm assuming you mean splitting it like in two halves, right? And then something travels from the one end to the other along that straight path, but to you it looks like a curved path. Is that correct?
Yes, you're outside of the merry-go-round.
Okay. So if you had a computer chip in whatever object you were talking about, right? And that computer chip could tell GPS or directions or whatever, right? Like they have in the NFL footballs. That would tell you that the object indeed traveled in a straight path.
No, dude.
Looks like
Okay, I'll start my stream, and then you watch it, and then you understand it. Maybe
No.
I did a poor job explaining.
Explain how I'm.
I probably did a poor job explaining. You can't be seriously disagreeing with it. Can you join live stream, please?
Is the ball deviating or not?
There's no ball, dude.
This could all just be summed up. The Earth is stationary. It's in the universal reference frame of reality. There is no outer space. There's no ball floating in space.
That's no fun.
Period. The end.
Very simple.
The end.
Okay,
the end. Now let's move on and actually discover more truth and figure out ways to work together and have synergy and discover exciting things rather than banging on about this false globe model that never existed in the first place.
I just want to try one last time with Regis, if possible. I know he can understand this.
Let's go into the fact that let's go into the not always heat. It's also dependent upon your reference frame, because if it's moving, it could be contracting from another reference frame. Let's go into that. That makes it even more fun.
Okay, Regis, you're slow. Can you join the live stream, please?
Because relative reference frames don't exist, let's go into all of the contraction and ad hoc. Okay, I'm just joking. Go ahead.
Yeah, they can't understand a straight line. Let's go into that.
Okay, so that's the path, the piece of wood that is stuck in the roundabout, and it's rotating clockwise, right? So this is the first moment, and the toy car is here. This is position 1 of the toy car, and it's going to travel in that direction while the piece of wood is rotating. So in the next moment, now the piece of wood is, well, where's the line? Wait, just give me a sec. Okay, here. Now the piece of wood have rotated, and it's like this. And the car traveled, so now it's no longer here in the beginning of the piece of wood. It's here. It's a bit further. So this is position 2. And then it keeps going further, and the piece of wood keeps rotating. So now the piece of wood is here. And the toy car is now in the middle. And the piece of wood keeps rotating. And next position, where the toy car is, it's now here. This position 4. So the path of the car here is doing this for you that is not in the merry-go-round. This is a curved path.
You did a terrible job explaining it, but now I
understand. Okay, that's what I was saying all along. If the car is going straight, okay, that's what I was saying. So Jeremy made the point that if the ball is following along with an object that we know to be straight, that means the path of the ball is also straight. And my point is, no, if that object's rotating, then that path can still be curved. Does that make sense to you?
Yeah, but then it's not a straight path.
You're moving.
That's my point.
The wood.
Sorry?
You're rotating the wood, though.
Yes, exactly. So if you place the wood in the ground and you go to the merry-go-round, now the opposite is happening. You still see the wood rotating, but now you're in the merry-go-round and the wood is not.
You realize that it's objectively doing what it's doing regardless of reference frame, dude. Like, in the first example, it was going straight because it was going straight. In this example, it's curving because it's curving. Like, I don't understand what your argument is.
You're trying to confuse things. That's what he's trying to do.
You're using the person. In both cases, you're saying that the actual one is the one that is not in the roundabout. That's fine. I'm just trying to get to the concession that just because it's following along with a straight object doesn't mean it's a straight path, because the object might be rotating.
Yeah, we were never saying that, though. We were talking about that specific example.
Now, that's what Jeremy freaked out when I said.
It's objectively doing something.
No, I was explaining this specific scenario because when I said that the object going along with a straight object doesn't mean it's necessarily straight, he freaked out. That's why I came up with this example. And I thought you understand, and you guys were saying it would still be straight, even though it's clearly curved. That's why I had to draw it. So at least one person can understand.
Scenario, I didn't understand. I agree with that. But the point you're making is still not combating.
What is the point I'm making?
Point. You were just trying to show that if an object's following something straight, it doesn't necessarily mean it's traveling in a straight path. But I wasn't arguing that. I was just arguing the first example that you brought up, and I'm just saying that whatever is going on with the reference frames, we can tell that something's objectively, well, even if we can't tell, something is objectively happening or it isn't. It's either going straight or it's curving. Like, there is an answer, and you're saying, no, it's dependent on the reference frame.
Well, when you say objectively, you're implicitly using an inertial frame. That's all that's happening. Whenever you don't say the reference frame and you say objectively,
Nah, dude, because
it's
if you're in the
clear.
other reference frame, it's going to look different, but you can't say that's reality.
Well, whenever you say the real in reality or the actual thing or what's objectively happening, it's clear to me that you want to take by default the inertial frame. That's fine. But that's what you're referring to
No,
when
I'm
you're
not
saying in
taking the
actuality.
inertial frame. You can use the other frame. You can use the rotating frame too.
No, in that
That's
frame,
only how
it's
you're looking at it, dude.
in that frame, it is curved.
It's not actually curved. It's not real. It just appears that way, bro.
I'm not discussing
I don't know
whether or
why
not
you're
it is
arguing
actually. I'm
It's
not
so
saying whether or
true.
not. I'm not saying whether or not it is actually curved. I'm
Yes,
saying
you
whether
were
or not.
You were.
You're
You were
double
saying,
speaking,
that it
obfuscating,
actually
bro.
is
My
curved
You're
on
God.
the other
just
reference frame.
bullshitting, bro, at
No,
this
I'm trying
point.
to get to the end of my sentence.
Yeah, yeah.
I'm
Remember
arguing
that?
whether whether or not it's making a curved path in the rotating frame.
No, you weren't. You were literally, this whole thing started because you were agreeing with SE saying that Xanax said that these things are actually happening in their own reference frame, according to their own reference
Yes,
frame.
in their reference frame, not like
No.
objectively.
Okay, but
That's my whole point.
it's still a visual thing. It's still you guys just saying, oh, wow, it looks that way. But we know what's really happening. You're pretending that we don't, that if we're in a reference frame versus another one, that whatever is presented to us must be reality. That's not true.
We're just referring to the inertial one whenever you see really happening.
No, you said earlier. No. Earlier you said that you agreed with Zanuck and that it's actually happening depending on the reference frame.
Yes, it's happening in that reference frame. There's a curved path in the
No,
reference
there's one
frame. This
answer.
is true.
No.
Yeah,
It's not
you're
reality.
using two. Okay, one sec. There are two meanings of word actual being used here. When you guys use it, you mean
We use
in
it,
inertial.
right? Yeah.
Oh my god. When you
Go
guys
ahead.
use
My
it,
bad. Go ahead.
right? When you guys use it, you mean in the inertial frame. That's not what I mean when I say actual. When I adding the word actual just means this statement is true. So if I say that path is curved in the reference frame A, and I add the word actual there, I'm just saying this statement is true. It's true that it's making a curved path in that reference frame. So it's actually making a curved path in that reference frame in the sense that that statement is true. Not in the sense that it's making also that in the inertial one. Of course, it's not doing that in the inertial one. But it's not what I mean by actual. It's what you guys mean by actual.
It's just sophistry at this point, bro. Just pure sophistry.
Oh, you got me.
Of course I got you. And everybody listening knows we got you. You said and you think in your mind that a ball could be both traveling straight and curving at the same time. It's sheer delusion.
No, only in different frames. Those statements aren't true for the same frames. Just like if you throw a ball, it can be going away from me, but it might be going towards you. But it can't be going away from me and towards me at the same time. Of course not. But there's no objective away or objective towards me. That depends on if I'm talking about me or talking about you.
Yeah, that's why I brought up.
Never mind.
That's why I brought up, like, let's say two people are standing in a field and they're throwing a ball back and forth. The one guy has normal vision, so he sees things as they are. The other guy has glasses on that just make everything distorted and colored. And the guy's saying, "Oh my God, the ball is 5 times bigger than whatever it is." Like, he's seeing through these funky colored glasses. I know it's a weird analogy, but it's almost like what they're saying is that for the other guy who has the glasses on, that's really what the ball is. It's a wonky, distorted thing. Like, that's what it actually is. What reality is, what that guy is seeing through his glasses.
Yeah, that's what they're saying, bro. Yeah.
I don't think that's very analogous. I mean, though the glass clearly is distorting light. So if you take notes of coordinates, they should still get the same coordinates, even if he had bad glasses. So I don't know.
It's not my best analogy, but it still fits because you're claiming that something could be curving in one frame and straight in another.
At the same time. At the same time.
Simultaneously, yeah.
Well, if you're already saying that it's different frames, and saying it's at the same time doesn't add anything. It's not actually in the same time. It's in this either on that frame or on the other frame. No statement is being made about both of them at the same time.
Bro, I don't know how you do it, but I don't know how you make sense of that. If you actually believe that, I don't know what to tell you, bro. Seriously. Like you're saying dog cat dog. This is what you're saying.
Well, it looks like
I don't understand what that means.
It looks like a dog. If I look at it from this, yeah.
Yeah, I'm on a merry-go-round. Hey, that's a dog. And SC says, no, it's a cat. No, but I'm on the merry-go-round. I see a dog. It's a dog. And then Bacon's basically saying, yep, it's a dog for the guy on the merry-go-round. It's a cat for the guy on the ground.
That's come on.
Yeah, exactly. Exactly. Yep.
I'm using analogies that don't really fit all of the components, but it is more or less. But it
that's
kind
perfect,
of is,
bro.
No, that is perfect.
No, it doesn't fit in either in no relevant way.
Well, it is because let's say it really is a cat. The guy on the ground he's correct. It's a cat. So if the ball's going straight, he's correct. It's straight. Just because the guy on the merry-go-round says it's a dog or says it's curved doesn't mean it actually is a dog or actually is curving.
Yeah, but there's no way you can change a reference frame to make a dog become a cat. But there is many ways you can change a reference frame to make a path become curved.
No, it's the same. How do you make a straight thing curved? You can't do that.
Use a rotating frame of reference.
That doesn't make something change its path.
Yeah,
it is because the path is. I mean, it's just like position. Saying what's the objective position of something. That doesn't mean anything. You need to establish a coordinate system for position to make sense. So
listen to me. He's trying to keep from laughing. Listen to him. He's chuckling. Come on, let it out. Come on, Bacon.
So, Bacon, are you actually arguing?
I wasn't done, dude.
Let Bacon go. Although I have to say, I remember that time when Flat Earth Data was in here. He kept saying, "Don't fuck around, Bacon." I hear you smiling behind your keyboard. Remember that?
Exactly.
That was funny.
I wasn't smiling that day, but I'm now.
But you can't have different coordinate. That was my point before about the XYZ. There is a universal XYZ in my viewpoint. There is a vertical and a horizontal, mix up an XYZ, etc. That's the difference. You're saying there isn't a universal XYZ. They're all different. So if you're going to do that, it's like contorting reality and then making all of these different realities that are not actually what is happening. It's conceptual.
I can for now agree with a flat Earth just to make things simpler, and even on agreeing on a flat Earth. There still would be no XYZ universal. The only thing that could be universal would be the Z-axis, because everyone agrees in which where upward is. But we wouldn't be able to agree unless we establish that first. Where is Y pointing at? Where is X pointing at? And where do those meet? Where is the origin of the coordinate system? And if different people establish that differently, the same house can have different coordinates.
I'm sure everybody understood that, right? That's clear? Crystal.
I hope so.
Yeah, that's different, though. That's like, I don't quite understand or know if I 100% understand what you meant there, Bacon, but you're kind of saying that you can create a different coordinate system with that example. But
yeah, coordinate systems are only created.
You can't create different coordinate systems depending on reference frame, though. They're two different things.
No, they are the same thing. A reference frame is just a coordinate system. That's the whole thing.
No, I know, but you're saying what you were just saying with that example was like someone. It was like akin to someone like just making a different type of coordinate system for the same layout. That's not exactly analogous, in my opinion, dude.
Oh, it is exactly analogous because a coordinate system is exactly what a reference frame is. Okay,
exactly
so
what
a reference frame is. So okay. Hear me out here for a while, for a second. If we establish different XYZ coordinate systems on the ground, we can have the same house having different coordinates, right? One coordinate for one coordinate system and another coordinate for the other coordinate system.
Well,
does that sound reasonable so far?
Coordinate system.
Sorry?
define or explain a little bit more what you mean
Fair
when
enough.
you say different coordinate system.
Okay, fair enough. So everyone agrees that the z-axis is upwards. So our vertical axis is z-axis.
Sure.
So now elevation is just a number in the z-axis. That's just what elevation is now. And we can establish that 0 is at sea level, mean sea level. Okay, now one person decides to put a dot on the ground and say that's the origin of coordinate system. That's where I'm going to create an x and a y value. So let's say they point y north and they point x eastwards in that point. So now they established a y-axis and an x-axis. So now every point in space can be referenced by that coordinate system with a z value for elevation, an x value for how much eastwards it is from that point, and a y value to how much north from that point it is. So now, let's say your house is 200 meters east and 100 meters north from that initial point. So the coordinates of your house is 200, 100, and 0 if it's at mean sea level. Now that's the coordinates of your house. We have an x, y, z coordinates that give me exactly where your house is relative to that initial point that I established. I could have established somewhere else. I could have established my x and y pointing in different directions. That would cause that same house to have different coordinates, right?
Yeah, but what was the original point you were making?
That's one very important one. If we agree so far, I can move forward.
I agree.
Right. Okay. So let's say now we're in a cruise ship, right? And we also want to be able to have position for things in that cruise ship. So now we can establish an XYZ position fixed somewhere on that cruise ship. And I can have positions for things in that cruise ship. And whatever is stationary in that cruise ship will have a fixed coordinate. So if I don't know, if there's a table somewhere in that cruise ship, that table has a coordinate. If that table isn't sliding on the surface, then that coordinate isn't changing, right? You following?
Yeah, you need to stop hanging out with Kosho. He's a bad influence.
I don't know. I mean, if no one's following, that's fine. I just play cards with my brother. But if someone's following along, I can try to get somewhere.
Yeah, better you go play Crazy Eights because you're making absolutely no sense, bro, when the Coriolis. Sorry.
All right. Okay, guys, have a good night.
I mean, you can stay and hang out. You don't have to leave.
I didn't admit, geez, you took it serious.
Yeah, if we set 2x4s up, we post them in the ground, we make them horizontal. We got a whole thing set up of these straight 2x4s. We know they're straight. We know how to make 2x4s straight. We can check to see if they're straight. If you get on a fucking roundabout and they look curved, well, we know that's not actually happening because we know they're fucking straight. There's a thing about what's actually happening and what looks like it's happening, right?
Bro, it doesn't get any simpler than that.
I remember when I taught you how the Coriolis effect works a long time ago. Remember that?
Oh, you remember that, huh? How thick-headed you were, huh? You remember?
Yeah. I've been wrong once or twice, so.
It's okay, brother. No hard feelings. How long did it take me, Jeremy? A year, I think.
Well, I was very adamant. Very stubborn.
Still think the explanation for hurricanes is bullcrap.
Well, they got them going clockwise in the northern hemisphere. Go ahead.
Yeah, I brought that up like a couple weeks ago. It seems like they should be the opposite direction in each hemisphere. And then they say it's an inward. What was Bacon saying? It's an inward motion or something? That's just ridiculous. Like, you have to make the wind slide past each other in order for it to turn the other way in the middle. It makes no sense.
I got a comment.
N-word?
Can I make a comment? Coriolis thing?
Yeah, what do you got?
In the non in the inertial frame, that's the frame that's that's the frame of the roundabout going around. That's the reference frame of the roundabout going around, isn't it?
No, that's the non-inertial reference. The roundabout spinning is the non-inertial.
Okay, so the non-inertial plane. I think what's really happening in that inertial frame is that the ball is actually traveling straight. It's the person that's viewing the ball that's actually turning.
Yeah, it's optical. It's an optical effect. Yeah. In fact, when I detailed it,
they're saying that the ball's turning, but really what it is there is some turning going on in there. You know, like there is a Coriolis, but the only thing really moving is the person making the view. The ball's going straight, just like in the other frame.
well, if that twist or noodle, wait till you hear about the force, the Coriolis force.
I've heard about
that's not it.
That's so crazy. Like an equation to figure out an apparent force. Like what?
Yeah, it's just what the force would be if there was an actual force on it. It's not actually happening. It's just what it would be if there was. If this wasn't, it's like they're putting a force to the optical thing. Oh, we see it moving this much. Well, let's put a fucking force on it, so that we can say this is how much force would be. What we would need if it was if it was actually deviating. This is the force we would need.
Well, what if your reference frame was underneath the ball, looking up?
Oh boy!
In your world, that would
What's up,
change everything. What's up, man? I'm just saying though, if your reference frame was underneath the ball, looking up, in your world, that would change everything.
What do you
Not
mean?
even relevant.
It's the same as being
Relevant if you understand the
optical from
question.
Okay, what's the question? What if you're underneath the merry-go-round?
Dude, if you try harder, you can repeat the whole question yourself because you did hear it.
Yeah, if you're underneath the reference frame, then what?
And yeah, you know, go ahead.
I don't know. I don't understand. I didn't think it was relevant, but now I don't know. Is it? Why don't you just repeat it so we could be clear?
All right. So if you're underneath the ball looking up, won't that change everything in the way that you're describing reference frames?
Are you on the merry-go-round or you're on the ground?
Let's say both.
I don't know, Branch. Whatever.
You're
yeah.
Okay, you know what? Let's start with the first one then. If you're on the merry-go-round, then what?
Then you're going to see the ball deviate off a straight line path.
And if you're on the ground, looking up,
it's just going to go in a straight line over your head.
So the only difference between your reference frame is whether or not you're looking up on the merry-go-round or not. And what's the difference between those two reference frames?
They're the same.
One's spinning and one's not.
Exactly.
Okay.
You cleared it all up for us. Thanks. We were fucking confused until that.
All right, bro. That's what I do, my man.
Well done.
I think it cleared it up for Regis. The slow bet.
Point for Branch.
You nailed that, bro.
You get a gold star.
I didn't even mean to, man. I actually came in just trying to say stupid shit.
Oh, we didn't know that was your plan. Thanks for telling us.
I was actually trying to somehow find a way to bring in bananas into it.
Don't anyone say the B word. What he wants.
Well, we got Coriolis all cleared up, so.
Did we?
Yeah, it's all.
Write it down.
Solved.
No, guys, I'm so happy I could help.
Well, it's a deep thing what they've done with this, though. It really is intense. I mean, the way that they've like relative reference frames, and in my viewpoint, it's just a major contortion of reality, and on multiple levels, and they've convinced people it is reality.
Yeah, reference frame just basically means if you look at it this way, it looks like this. Remember back in the day when DVD came out, right? And you could watch certain scenes in different viewpoints, which was never before be able to do, right?
Right. But let's say in that analogy, you would have
it doesn't mean that the movie is different.
exactly.
It just means that you're looking at it in a different angle.
That's what I was going to say. When they filmed the movie, it was that they were in reality. They were doing whatever they were doing, and it's filmed from different angles. So yeah, you can watch it later from different angles, but it's still the actors in the same physical space. So that's why that kind of does link into what we were talking about. If the ball is going straight, it actually is going straight. It might be viewed as curving from another perspective, but that doesn't mean it actually is curving. But these guys are saying it actually is curving in these other reference frames.
I mean,
anyways,
whether or
let's
not
not
the
go
ball's
back all of it.
curving or not, it definitely depends on your reference frame.
No, that straightened it out. We really straightened out Coriolis.
Yeah, I think we're good now. I think we got it.
We just need to do another 12-hour session with Zanuck, and then it'll be finished.
Oh man,
I can't believe he didn't fucking come in. I'm gonna taunt him with this and tell him we had a nice little 6-hour Coriolis chat, and he's gonna start fucking spazzing.
I mean, I can imitate the condescension if you want me to.
It might help.
Are we good?
I could try interrupting every 10 seconds.
Yeah.
No,
Just a
no.
minute,
Let's
right in the middle, someone's
do it.
talking.
Let's
So
do it.
Jimmy-
Let's do it. Napalm's gonna imitate, and we're gonna go from there. Go ahead, Napalm.
Well, I know that this isn't the easiest thing to understand, and I understand if you guys don't comprehend it.
No!
I'm not done. But I think if you guys took a physics course, you might start to begin to comprehend this. Okay? I'm just joking.
Yo, what physics course I gotta take?
Well, Charlie wants to pay people to take a physics SAT, apparently.
Yeah, but they don't even do physics SATs anymore. Like,
I took that.
Yeah, but they shut it down in like last year.
No more SATs?
No more subject SATs. So they still probably have the English and math.
I remember I was really hungover when I took the SATs. I was up partying all night and probably only got about an hour of sleep and had to go and take the test.
Dude,
Honestly,
you too?
yo, I didn't realize how important.
I think half the
SATs
room was
were.
probably hungover.
Bro,
the same
I
shit with me,
literally
man.
the same thing happened to me. My parents went out of town, and my older brother threw a party, and I had to take the SATs the next morning. I literally got like maybe 30 minutes of sleep, and I show up at the SAT, and not only am I sitting next to the most attractive girl in my high school, I have a friend that's in front of me and turns around, and they're like, "You reek of alcohol." I'm like, "Well, I'm kind of drunk." They're like, "That's real smart."
Bro, so we totally cheat on SATs. Like, I didn't cheat. I kind of let somebody else cheat though. Like, because there's only a certain number of papers, right? And we're sitting in this row, and the dude across me had the same paper as me. And so, like, I thought he knew English because I don't really understand this whole American English shit with the whole fucking this means to that and that means to what. You don't get taught that shit in England, right? And so fucking, I'm doing the math bit, and I'm like, all right, bro, you copy my math shit, I'll copy English shit. I didn't realize this was a dumb fuck. I thought his American English must have been better than mine, so I copied this. This nigga, I mean, this guy got a really good fucking score in his math, and it was like, whoa, you must be really smart then. It was just funny because he just played it off. Anyways, that was enough me time for a second. Let's start getting one of my stories out.
I'm glad I'm not the only one that was like extremely hungover, if not pretty much still drunk when I took my SAT. I'm glad to hear somebody else did that as well.
Nah, dude, I was hungover as fuck when I took my AP Physics class, though. AP Physics test. Because, like, everybody else was out partying, and I wanted to go party. But it probably helped me, because, like, sometimes when you're a little bit drunk, you know, your mind can be loosened up a little bit. I'm so about to be muted.
In the roundabout example of Coriolis, Does the whole does the heliocentric model really need the ball to be taking a curved path in order for it to all work out for them? Is that why they cling to this so much?
Nah, bro, we cling to it because, like, we're usually the ones on the bottom of the what's it called, the merry-go-round, whatever the fuck.
They don't need it, right? It's just one of their "this is how we know the Earth is a ball" claims, right? Is this convoluted Coriolis?
Like, I guess the question is this: when you throw the ball, why does it move in a banana shape?
It doesn't. The person on the roundabout is moving in a banana shape.
Exactly. That's the point.
But it almost seems like this whole argument sort of weakens the ball, because if we were on a spinning ball, we'd see that the curving. We'd throw a ball and we'd see it curve, or a rocket ship, or whatever we can throw out in a straight line, we'd see it curve, but we don't. So it's almost like counterproductive to keep arguing this point. I know they say that
imagine this, yeah. Imagine you are on a merry-go-round, and it's moving at a speed of 1 circle per day, right? It's moving, like, if you want, half as slow as the hour hand on your watch, right? Now, in that case, if you throw a ball and it's moving at that speed, half as slow as the hour hand on your watch, would you see it, twist a little bit?
Well, yeah, because it would seem like you would see it move, because
it's moving half as fast. That merry-go-round is moving half as fast as the hour hand on your watch, and you expect to see a difference when you move. If you basically throw a ball at my noggin, right, and you know that shit's moving at half the speed of your watch, are you gonna take into account that half speed of your watch rotation?
I don't think that's a good analogy.
It's a perfect analogy.
Have you ever shot a rifle?
But see, the surface of the Earth is not moving half as fast as the hour hand on your watch, right? That might be the case if the hour hand on your watch was 4,959 miles and you were on the end of it.
It doesn't matter when we talk about what.
It doesn't matter.
The things we're talking about right now is about Coriolis, right? And
right, but you brought up
scale, it won't make a difference. You can scale that shit up. You can scale that shit up as much as you want. It won't make a difference. Because you know why? Because you look at the formulas for it, R actually drops out of the formula.
I think a better analogy would be like if you were going 1,000 miles an hour in a circle, and you threw a ball out the window. That ball would look like it's moving in a curve, even though it's going straight. I mean, yeah. If one reference frame is moving at 1,000 miles an hour next to one that's still, if you threw something out into the reference frame that's moving 1,000 miles an hour, the ball would just go back. It wouldn't go straight.
All right. So you know what? Again, you're moving forwards with this, but let's take a step back and reaccount that same situation on what we were talking about before, where the merry-go-round. Like you're going big scale and low scale. Let's answer it on one scale first, and then we can move back afterwards, right?
I don't know why you want to go backwards here.
Because again, I don't think scale matters, and I think that's the problem. Is that
I'm not talking about scale.
When you can understand things in small scale, but I think there's a problem. There's a problem when I try to make you understand the same shit at a larger scale. Now, the thing you got to understand is, like, if it works on a smaller scale, if you expand that scale out and make it as big as you want, right, it still fucking works.
Yeah, that's what I'm saying. Is that on the merry-go-round, you're at a smaller scale, and you see the ball curve, but it's not really curving. On a larger scale, if you were on a ball going 1,000 miles an hour and you threw something off that ball, off that merry-go-round into a reference frame or just into the air that wasn't moving at that speed, the ball would just it would look like it was curving just like it on the merry-go-round.
I guess a simpler way to say this is like, let's say we do one experiment, right? On a roundabout that's, let's say, I don't know, maybe 15 feet in radius. So we observe something of 15 feet of radius, right? And regardless of what we observe, you throw a ball at me and while it's spinning, and we observe it, right? Now let's say we scale that shit up 1,000%, right? And we do the same thing again, right? And this time, if we're gonna scale up the size, you're gonna scale up the force you throw that ball because it's gonna get to me, right? You can't just do a little pansy throw; it's gonna fall on your dick. So you scale up the force you throw it with, and you scale up basically everything. Do you expect the ball to move differently just because you scaled it up?
Either I'm stupid or I'm not getting your argument at all.
Yeah,
it just doesn't make sense at all. It's just like if you're an inertial, non-moving reference frame, it doesn't matter which reference frame you're coming, which angle you're coming from. If you're in a non-inertial reference frame, the ball will always appear to be going in a straight vector in free space, and especially if you relate it to the Earth, which is not moving. And there's no evidence for the Coriolis actually deflecting any object over the face of the Earth in a constant velocity one vector.
Have you ever had a chance to play with the Burris Mark II Eliminator scope?
I don't know what that is.
I mean,
Is it a child's toy? Or?
Everybody get a chance to play with that shit?
Yeah, I mean, you can go into your local Cabela's or Big Five shooting goods and, take it off the shelf and look at it and have the guy behind the counter tell you how it works. And what he'll explain to you.
Okay. I guess everybody should have.
Branch, you're interrupting him. Don't make us have to mute you. Go ahead, Kool-Aid.
What he'll explain to you is that inside the laser rangefinder, it has two things. One is a Bluetooth connection to your phone. You can get accurate temperature as well as wind readings. And then it has a laser rangefinder. You give it, the Bluetooth is also giving it your GPS position and the direction it's pointing. You aim at your target, whatever it is, say it's a deer 2.5 clicks away or whatever your target is, and you push a button on the scope. It will fire a laser blast downrange to get the exact range. It will also take a snapshot of the weather conditions. It will then move the aiming reticle across the scope, causing you to readjust your aim because it knows if you pull the trigger, then you will hit the target.
Dude,
there you go. So that's adjusting for the weather. There's nothing to do with the Earth moving.
So two of those corrections that are being applied in that scope are Coriolis and Otvos.
And those two corrections for Coriolis in that scope are factitious and fantasy. Absolutely, there's absolutely no evidence for this technology.
Other than the Burris
This
Mark
technology
II
is great for the army, right? But can you imagine going hunting with that? That would take all the fun out of hunting. Like,
it's
how
bullshit.
would hunting be fun using tech like this?
Where's the patent for it?
I'm just saying, bro. Like, when you go hunting, you don't want something aiming for you. The point of going hunting isn't to make tech aim for you.
All right. So are you saying that this scope incorporates Earth-based Coriolis and Eotvos effect, Kool-Aid? Is that what you're claiming?
Yes. At least that's the claim according to Burris, as well as the people who are smarter than me and have dissected the code that is running in the scope.
Do you think it really works? Do you think it
What
really
model
has
is
some
that?
effect?
Does the scope? If you said you looked at the code, does it correlate for Coriolis?
What model is
That's
that?
what I'm told. It's the Eliminator Mark II.
Well, we were also told that they're flying up and landing on the ISS, but that's not true either.
I doubt it does correlate for Coriolis. It's not needed at distance.
It is at over 2 kilometers.
Yeah. So this
See,
thing,
this is a clear
who
example
the
of how
hell hunts
people
at
just.
2 kilometers away?
This is a clear example of how people will just believe anything they're told.
No, I'm giving you an example of where you can actually put this technology in your hands.
Yeah, you can put it in your hand and you believe it.
And it
Yeah,
works.
but the tech you just
It
talked about,
works.
I'm pretty sure it's
What's
not stable to
working?
work at
Maybe
200 kilometers.
it's deflecting due to the weather conditions. Nothing to do with the Coriolis. So you just believe everything you're told.
That's a
Need to do some
different
research.
line of code. It does both.
How do you know it's
No,
actually
it
doing
doesn't.
anything?
I'm sure
Because
it doesn't, bro. Like, I swear to God, I'm sure it doesn't. Because if it
it
did,
ru-
it would need to have a GPS system in place just to be able to know which direction it's facing and, you know,
Branch,
where it
it
is
gets
on the
that
Earth.
it gets that information from your phone.
Does have a GPS system integrated. I'll be honest with you. Who the hell
Right.
hunts at 200 kilometers away?
At 2 kilometers away.
Okay, even 2 kilometers away.
Yeah.
Have you ever hunted a boar or, I don't know, what was it? Santa's little
My
helper?
my
At 200
longest
kilometers
shot
away.
is about 2.5 kilometers.
And would you have felt proud about that if you had used a computer assisted aiming system?
I did.
Oh my god!
That's
Why
how I
you
was able to
that's
ensure one
not
shot.
something to be proud of. That poor little animal had no chance then.
What is that model called again? I'm gonna look it up. Mark II scope. What was it?
It's the Burris Eliminator. Here, I'll drop a link.
So you was actually proud of killing an animal using computer
The
assisted
newest one is a Mark V, so I don't. You can probably
is it?
the Mark V. Yeah.
Yeah.
Did you go collect that? Did you go collect the body and eat it afterwards, or you just left it there?
No, I don't eat. I don't like
So
paca.
you basically use this to kill an animal at 2 kilometers away, about what? That's a mile and a half ish, right? And you just left it there to rot.
Branch, that's not even the topic, bro.
And it was not left there to rot. It was taken care of and disposed of.
There's nothing to do with what we're talking about.
No, it doesn't.
Yeah, don't take it there. And that is the best way to harvest an animal if you're trying to go down that road. Anyways.
What, to kill it two almost a mile and a half away?
Yeah, you have
One
absolutely
shot.
no idea what you're talking about. So
I'll be honest with you, why
we'll
even use
move
real
on.
bullets?
It was one shot that
Honestly,
hit in the
the
vermilion line.
best way to go hunting, I think, is using bow and arrow.
The best way to do it is to respectfully harvest the animal so they feel no pain.
Well,
Yeah.
bow and arrow. The problem with bow and arrow
that's
is
not
it's very
necessarily
hard
with an arrow. You have no idea what you're talking about here, Branch. But
with bow and arrow, you're gonna make them feel a little bit more pain.
Exactly. So the range on that scope looks like it's about a little over a mile.
But the chance the animal had to live was greater.
Anyways, Branch, we're not talking about the fucking animal, bro. We're talking about the scope.
We're talking about this scope and the fact that Coriolis correction is one of the lines of code that is operated every time you hit the button on the scope.
Where do you have any actual evidence for this? Because according to Burris's website, it mentions absolutely nothing about a correction for Coriolis.
Sure, stand by.
I wish we'd get Jace back here because I've got some questions I want to ask Jace about evolution. Let me see if I can get Jace back here.
Most of the stuff I'm reading about here is windage.
Yeah, I mean, Kool-Aid, did you read somewhere that they claim they incorporate Coriolis, or is it just something you assumed? Or
No, it was actually something that they talked about. It was in one of their brochures. I'm trying to stand by. I don't shoot anymore, but I keep up to date on most of it.
It probably also said that you're going to be able to play the piano tomorrow and pick up lots of chicks too.
maybe guitar. Chicks dig a guy that can play the guitar. I don't know about piano. Definitely guitar.
And you got to play it with your teeth behind your back.
There you go.
If you don't play a musical instrument, you can always like just pretend you're such a fan of the instrument that it doesn't matter if you play it or not.
I'm not taking your advice on how to attract women, Branch.
Oh, bro, trust me, man. I know how to get that part of the woman's mind that like will never let go with you.
Never let go. So you're married?
It sucks. No.
Okay.
And that's the thing is like when shit's too easy, you don't want it.
Oh, that's cute.
That's not that. I just enjoy being single. I like to be myself. I don't like having responsibilities.
It'd be great to do a test from a high altitude with like a cannonball and just drop it from a helicopter or something like that, and to see how many kilometers it veers off course from straight down.
Have you ever ate a banana?
So yeah, that's a good point, right? So the claim about the pendulum, the swinging action of the pendulum, is allegedly creating a different plane, right? So it's the claim is that it is no longer the same reference as the Earth, right? So the pendulum's deviation is allegedly showing the rotation of the Earth, because as the pendulum is moving, you're creating a
No, the whole focal pendulum, the whole thing is attached to the Earth no matter what.
Right,
it's attached to the Earth in every single way. The only way you could test it is something in free space falling to the ground, and then you could see if it lands in the spot that you're overhead, or if it's going to deviate from that.
Yeah, so to me, that's why I said it's a good point, right? Because if you go up extremely high and you drop something straight down, why would that be any different than the movement that the pendulum is
Because the
experiencing?
pendulum is attached to the Earth in every way, shape, and form.
No, I get that, but I'm saying from their perspective, their claim that is a free moving pendulum, right? So as it's dangling there, the fact that it's attached to the Earth makes a difference. But once you start swinging it, right, and that motion that it has, that momentum, that creates, in their mind, don't come at me, bro, is that creates a different, I don't want to say, I can't remember how they phrase it, but a different frame of reference to the Earth, so that it will show a deviation. So if you have an object and you drop it and it's in free fall, if an object is in free fall, how would that be any different than the alleged reference frame that is created by the free swinging pendulum that's attached to the Earth? So you should see a deviation in a dropped, like, heavy bowling ball. You should see a deviation if there is movement, like a large deviation.
And I just there's no way I can imagine deviation for some influence from the wind.
Yeah, I mean, you could maybe get a little influence from the wind, depending on like how heavy your object is. You'd certainly want it to be perfectly spherical as possible, if not have, some, well, I don't know if you'd want dimples like a golf ball, because then you might get deviation if it starts to spin.
Golf balls are pretty light too.
I was just talking about the dimples, not specific golf balls. So.
Consider the dimples actually helped. Like, that's the most scientifically proven aerodynamic configuration of a ball you could ever have, right? Like the amount of
I don't know 100%. So I think you'll get more velocity on your, so like if you have a golf ball with dimples and one without dimples and you strike them the exact same with the golf club, it's my understanding that the dimples will allow the ball to have more velocity due to the aerodynamics of it. But I think
it's not
it's
about velocity.
possible that the spin rate
it's not even
would
about
cause
air
it to
resistance.
actually deviate more while it's spinning due to the dimples, but I could be wrong on that.
Actually, what the dimples do is, as it moves through the air, it creates it doesn't create, it uses the drag to propel itself in some ways. So
yeah, it's a velocity thing, but I think the spin will over exaggerate like a deviation with the dimples as opposed to without the dimples.
Yeah, I don't even know. Like, we should be talking about bananas, and we're not. And I think that
then maybe bow out of the conversation. I don't know.
No, it's not that. It's just that when I go off on a tangent, like I think we're going off on a tangent, and it's probably making Gio mad. So maybe I shouldn't have talked. Sorry. However, do you think there are better ways to have dimples on a golf ball?
I think we need a new topic.
So I'm going to go ahead and retract what I said about the Burris. I find lots of people who are talking about it, but nothing actually from Burris confirming it. So at this time, I can't back up my shit. So I'll stand down and stand corrected.
I appreciate that, Kool-Aid. I appreciate that you actually like retract that and don't double down.
Yeah. It's weird. Like, it might just be a commonly held thing that everybody believes because it's on all the forums, but.
Yeah, but they're actually saying that it helps you account for Coriolis and Eotvos in particular. I mean, I understand the idea of like temperature and GPS, and there, I'm not doubting. I haven't looked into those, whatever, but I'm not doubting that they have like a Bluetooth thing that connects with your phone and does some, GPS and some of that stuff. But you're saying that somebody actually was saying that it somehow is able to accommodate for Earth-based Coriolis and Eotvos?
Yes. That's what the claims are. Like I said, I'm seeing that all over all the different forums and whatnot, but for some reason I am unable to put my finger directly on Burris themselves saying it. So,
hey guys, I hate to bring back up golf, but why is there not one golfer on this planet that counts for Coriolis?
Because none of them are strong enough. It's the small pants that constrict their balls, so none of them can actually swing the club and hit it far enough.
Like all the shit you're talking about and shit, you would expect golfers to account for it, right?
I figured you were going to troll, but I mean, that actually is, you were going to say something more trolly than that. But I mean, Neil deGrasse Tyson did say that field goal kick in football was affected by Coriolis. So if that was the case, I suppose you would think that golfers would at least somewhat have to incorporate it.
Right. If the ball that they use for golf is designed to cut through air resistance, right? Then the only force that should really fuck up the shot would be Coriolis. But not one golfer on this planet accounts for it.
Yeah, there's account for wind and
you don't see them going, you know what, this is my latitude, and all right, this is the direction I'm facing, so therefore I should swing a little bit that way.
Yeah, but I think even like to try to defend the globe side, they would say it's so minimal. Like when you're putting, for example, in golf, there's all kinds of little variations in the blades of grass. You can't really realistically incorporate all of that, you know, so you still got to kind of take your shots. So they might say even if there is Coriolis on a golf course, it's just such a minimal factor that it's into that kind of uncontrolled variable factor.
That's the thing. Like Coriolis does affect them, right? But because the atmosphere is compensating for Coriolis, they don't have to account for it. That's the reason.
Bet you Zanuck would correct for Coriolis when he's golfing.
That's true. We should ask Zanuck.
Well, that's the thing. Like all the claims of alleged needing to compensate for Coriolis, you know, snipers, things like that. There's so many factors, right? Like you can try to take windage into account, but a slight gust of wind somewhere downrange that you haven't accounted for can cause you to be off target or on target if you were aimed incorrectly, right? So there's so many factors that come into play that there's no like silver bullet, let's go out and let's test the Coriolis today, and boom, we have this experiment that we do that Coriolis is dead on every single time that we do
some
it.
of these golf shots are just as far as some of these sniper shots.
No.
So if snipers need to,
not even close. Not even close.
How?
Yeah.
What? Okay, whatever. I'm not going to try to defend that one because you're right. It's not even close.
It's like not even a fourth of the distance.
You're right.
But yeah, it's a good point, Napalm. Like a gust of wind, temperature changes, pressure changes, all of those factors that would be involved to claim that you're going to make this little teeny bit of adjustment over that type of distance to account for Coriolis. It's pretty unrealistic.
Okay.
And especially when you're talking about shots that long,
this is
the slightest deviation.
Distances of golfers, Coriolis doesn't matter. But the distance of snipers, it does. Is that what I'm getting?
I mean, the claim is that it does, right? And the claim is somewhere in the manuals for long range shooting, it says to account for it somewhere.
All right. If you got like
does it actually happen? Do you need to actually take it into account?
If you got a super gun like the one that Germany built to, shoot something all the way to England, then yeah, you probably do need to account for Coriolis.
If you want a real answer, from my experience, 99.9999% of the time, no, it doesn't matter. Your shots are not far enough that any of that actually makes a damn bit of difference. But there are the outstanding shots that have been made at distances and ranges that are long enough that do require that calculation. So it's in the manuals.
It's a thing of the past, though, right? Like we don't really have ballistics anymore, and I hope they've retrofitted these ballistics because we shouldn't have ballistics anymore that are purely relying on projectile motion.
So let's say Kool-Aid. So let's say you're shooting north. Would that be where your most of your Coriolis is going to be felt, north or south directions in your shots? So what would be your deviation from your normal setup, all things considered being the same? So you have a left to right wind of the same amount in both shots. Everything's the same, distance is the same, temperature is the same. Everything is legitimately 100% the same in the shot. What is the correction for Coriolis when you're pulling that trigger and you're taking that shot that's over a mile long?
Right. Without actually running the math and figuring out how fast the bullet's moving and everything, My gut reaction is a third of a mil, maybe half of a mil.
Probably more like a third is probably correct. But even if that's the case, right? Over that kind of distance, if you correct for that third of a mil or you don't correct for the third of the mil, your chances of hitting that shot are slim to begin with. You know what I'm saying? It's not dead on enough to where you could set up that 2-mile shot that's going to show the alleged Coriolis. And if we do or don't account for it, all things considered the very same. We have the same shot in an east to west positioning, all things the same. There's just too many factors to say whether that correction is needed or not.
I disagree. I think that factor is very much in when we're looking at these outlying shots. And as the shots get bigger and we start looking at naval gunnery, then the Coriolis effect is very much in play and must be accounted for. For most sniper shots, we're talking in well within 2 kilometers, which it doesn't actually matter.
Right. Do you think that the really good snipers actually bring out
Chris Kyle?
Okay, so do you think actually he considers his latitude, longitude, and uses a compass, figure out exactly where he's at, accounts for the tilt of the Earth, because he's not facing true north with the thing, right? The north he cares about is the spin Earth. Do you think he does all that right before he takes a shot?
Define right before. So, because all that information is in your dope book. So you just flip open your dope book to get your.
This is like the moment you come up and you're chilling, you see your target, right? At that point, you're trying to aim. At that point, you should be accounting for your longitude, latitude, right? And your direction. And when you consider your direction, if you're talking about your direction to true north, that's very different to a compass direction, isn't it? Because the spin has nothing to do with the what shows on your compass. The spin of the Earth, if you're talking about Coriolis, that's accounting to the that's called true north. Is that true north?
So the way it's done in practice and the way I've seen it done is when you move into a position, you would actually draw a diagram of your shooting position and all of the buildings, the trees, or whatever's out there, and you'd get a range and a distance to everything in there. So when a target of opportunity was able to present itself anywhere in that field of fire, you could immediately look at your chart, get the exact corrections you need to make to put that round on target with one shot cold barrel. That's what a dope book does.
Interesting. That book takes account into where you're at.
Correct.
Okay. Well, that answered my question. Can we?
For ranges under 2 kilometers, the correction is nothing. Your breathing makes way more of a difference. So
Yeah, I mean the interesting is we're talking about old shit type of aiming, right? Like today's new aiming. Pretty sure that we can create guns that can just do the aiming shit for you. If you're saying that book, it seems like there's a bunch of numbers that doesn't change over time because it's in a book.
Right. The sniper's job is
into the
not
gun, into the aim of the gun.
The sniper's job and the power is not actually behind the gun; it's behind their ability to get intelligence and resources and extract.
It'd be interesting though to actually talk to real good snipers because I'm pretty sure, the really good snipers, they just feel the shot. Isn't that a weird thing about feeling the shot? That actually means something when you actually take a shot. And why is it that people that actually do teach their grandsons and shit how to really shoot long distance? They will talk about feeling the shock, as opposed to looking at Coriolis and all this bullshit.
I'm not sure the way I was taught was with the math of the numbers.
So when you got taught how to shoot a shotgun, your dad was like, you know what? Look at this book. Make sure you know your weight, where you are, longitude, latitude. Correlate that to what the book says, and then aim a hairline differently.
So, Batch, you've made an assumption about me, and it's kind of funny, but my father wasn't around when I learned how to shoot.
Bro, I do apologize. I did not mean to.
No, it's fine. My father wasn't around when I learned how to shoot. That would have been a drill sergeant.
Making me feel bad again, bro. Like, it ain't gonna change. I'm probably gonna continue feeling bad until the conversation topic gets changed.
No, it's fine. But I learned how to shoot in the military, and the way you do it is by the book and by the math.
So, who taught you how to shoot a gun?
Who taught me how to shoot?
Yeah, like
instructors.
I think the point of what you're saying is that your dad didn't teach you how to shoot a gun, and somebody else did.
Right. The drill sergeants taught me how to shoot a rifle. My long range instructors taught me when I went to Bravo Force School. I was the medic on staff there for a while.
Yeah, it's weird though, because like the more we talk, that whole fucking I'm feeling bad shit comes across, right?
No, it's fine. I found it humorous, so.
You find it humorous that I talked about your dad.
No, I find it humorous that. Never mind.
I'm sorry, because that's what I'm feeling bad about, is the fact I talked about your dad.
Oh, I don't care about.
My dad's dead, and I felt bad.
No, my dad's still alive, dude. He just wasn't there.
Oh, my bad. I'm sorry for
my
presuming
dad
your dad was dead.
My dad's a dirty hippie.
Have you ever tried to? Okay, now the conversation go out of hand. Like, have you ever tried to hook up with him?
What?
Have you ever tried to hook up with your dad?
Can I change the subject for a minute?
Please.
Yeah, Branch is done. Go ahead.
I would. Larry posted an article from the Daily Beast. It was about relativity and stuff. And it's a science article. I just like to read something from it. It's kind of funny. It says a team of distinguished scientists from Harvard, MIT, Caltech, Fermilab, and Google reported that they had run a process on Google's quantum computer that could be interpreted as a wormhole. Wormholes are tunnels through the universe that can work like a shortcut through space and time and are loved by science fiction fans. And although the tunnel realized in this recent experiment exists only in two-dimensional toy universe, it could constitute a breakthrough future research at the forefronts of physics.
The fuck is a toy universe? Anybody know? Toy universe? Is that what it said?
It says TOY.
Sounds to me like they're just floating that out there as if like it has some relation to reality, even though they're admitting it doesn't.
Gives an analogy a little further down. It says, If your neighbor told you she had 2 cats, one live cat and one dead one, this would imply that either the first cat or the second one is dead, and that the remaining cat, respectively, is alive. It would be a strange and morbid way of describing one's pets, and you would not know which one of them is likely the lucky one. You would get the neighbor's drift. Not so in the quantum world. In quantum mechanics, the very same statement implies that the 2 cats are merged in a superposition of cases, including the first cat being alive and the second one dead. The first cat being dead while the second one lives. Also, possibilities where both cats are half alive and half dead, or the first cat is 1/3 alive while the second feline adds the missing 2/3 of life.
That's a horrible analogy. Nothing could be half dead or a third dead. You're either dead or alive. There's no gray area, right?
What's your answer to Schrodinger's cat?
Yeah, it's just another play on Schrodinger's idea that he put forth.
Right. Because if I agree, it's a binary, you're alive or you're dead. But until we know, you're in a superposition where you can be said to hold both positions.
No.
Whatever.
Because even if you don't know, you're holding one of those positions, not both. Right?
No.
Like I have a dog that's alive, and we had one that passed away last year. If I said I had 2 dogs, the same kind of scenario, at no point is my dead dog in a superposition. Regardless of whether you know whether it's dead or alive, that dog is dead, regardless of whether you know that it is or is not.
Okay. If you say so.
I mean, do you disagree that there is some sort of objective answer to whether? Yeah, so there is an objective answer. So if you don't, oh, you disagree. So if you don't know, then that thing could technically be both. Even though there's no possibility for it to be both, it's either one or the other.
Correct. And by the act of not knowing puts it in a superposition of being both and neither simultaneously. Or, I'm sorry, it will be one or the other.
Well, it's obviously one or the other. Things are either dead or alive. They're not in a superposition until you confirm it. They're either one or the other, regardless of your confirmation.
As soon as you confirm it, you remove the superposition. Until you open the box, you don't know. And therefore, it is both alive and dead. It holds the superposition of being both. whatever, philosophies for nerds. So, how about that sports ball team?
Which one? Which sports ball team? Some sports don't have a ball.
Well, there was a change in the leaderboard for the GGR.
Nobody cares about that.
I think it's kind of cool. The girl who's now in the lead is from South Africa. She's an amazing sailor. Helmswoman.
Would you consider sailing a sport?
Yes. And depending on what type of sailing, it can define as either a team sport or a endurance sport.
Sailboat racing is my favorite sport. I'd love to do that.
Oh, you like sailboat racing?
Yeah, I don't have a boat now, but I wish I could still do it.
What kind of boat did you sail?
I had a boat, it was called a Feather. It was a 27-foot sloop.
Okay.
You know what a star is? A star is a 17-foot boat. You know what they are?
Oh, yes.
It's a star. They took the star and just made it 10 feet longer and put a little cuddy cabin on it. A keel.
Interesting.
And, yeah, and it's a double-ended. It looks like a canoe kind of. It's double-ended.
Mm-hmm.
And I used to race that down in the Santa Monica Bay when I was a teenager.
Excellent. You done any blue water?
No, unfortunately not. I think I would really like to do it, but I never got a chance.
You know, there's a really cool race going on right now. The GGR stands for the Golden Globe Race. This is the endurance side of the sport. These athletes left from France and sailed south, turned underneath Africa around Australia. They're now coming up on South America, where they will turn again and head back to France. And there's only one person on the boat. The whole trip will take them just about a year. They've still got 8,000 nautical miles left. You ever heard of?
Yeah,
You ever heard of this race?
There's quite a few races that follow that course, pretty much, huh?
Yeah, there's a number of them.
And there's quite a few sailors who have done that, like Chichester. I don't know if you ever read his book. Sir William Chichester did it single-handedly. I think he had maybe it was like a 70-foot boat or something. He sailed single-handedly. Mm-hmm. Yeah, that'd be quite a race.
So, have you ever? Do you know why they go as far south on that route as they do?
I mean, if you're thinking about the globe, you would say that you're just getting down below where there's any land. You can take that straight path. That's what I would say if you're on a globe, but it might be different on a flat Earth.
So the reason they go as far south as they do is the further south they go, the less distance they have to travel.
Yeah, that would be true on a globe, huh?
Right. And that's what we find, that the further south they go, the less distance they actually travel.
Uh-huh. But I just saw a movie recently about a girl who went the other way, and I actually met a guy out in Nicaragua who had sailed the other way, and yeah, that sounded pretty treacherous too.
Did you get Kool-Aid's point though? That the further south you go, the less distance you cover?
Yeah, I don't know much about the mileage or down there. I've never raced down there.
Yeah, so a lot of the races do a really good job about social media and putting up their information. The Golden Globe is still going on, and because of the nature and low tech of the race, their tracking is actually kind of bad. They have it on a different app, whatever. But the Vendée Globe does a really good job. Their information, as it's a full tech race, it's updated every 5 minutes using the GPS position as well as the satellite direct communication with all of the boats every 5 minutes. So we know everything about that race.
Yeah, if you consider all the information you get about those races, you can get on it, like you're saying, all the coverage by social media and stuff. It is, if you believe everything that's going on, it is a really convincing argument that you would be going a shorter distance down there. I don't, I think it is good evidence for that, but I can't really. What would it be? I can't really go there in a sense. Check it all out. It is pretty good evidence. If all that's true, I admit that.
So they hug the coastline of Antarctica as much as possible. Is that what you're saying?
As low as they are allowed by the rules committee, which does leave quite a margin for the ice, because fiberglass holes and ice don't get along real well.
And they do it when it's summer down there too, so it's not the most extreme time of the year.
I mean, you can start the trip in the summer, but it does take a whole year.
I mean, you're down there, and it's the warmest time of the year. I'm not saying it's warm down there, but I'm just saying they do schedule it that way so that you hit those lower oceans when it's more favorable. I know there's huge storms, and all that. They don't send them down there in the dead of winter. You might leave, Europe or something, when it's colder and winter time up there, but you're heading into the southern areas where it's summerish.
The GGR left last summer. The Vendée Globe only takes about 40 days, so they can do it much faster.
I remember reading a story about one of those races. It was one of the single-handed races, and some guy cheated and waited down by South America or something and hung out and waited for the race to come back around and then rejoined it. Did you ever hear that story?
No. That he would been called out immediately.
What's that? Well, it was called out. It was in, all kinds of, I think I saw it. It was a documentary on TV.
That's kind of funny, though.
And then there was another guy who won the race. No. What it was is the guy that cheated. Won the race but wouldn't come in or something. But There was another guy who went around Cape Horn and just decided to keep going and did the whole thing over again just by himself. Some weird thing. I think he died though, or in the process, or something. It was really a weird race. What happened?
Do you remember the name of it or anything?
No, it was one of those single-handed races that I don't think they even stopped. You know, some of the races with the crews, they'll stop and they'll hit, like Australia, New Zealand, and stuff like that. This was, I think, there were no stops. You had to keep going.
It's a pretty common racetrack that is used, and they use it because the mileage is well known and these distances are extremely well mapped. And if somebody thought they could cheat by, going further north and not having to travel as far, they would definitely do that.
Right. It is, on the globe, it is the most sensible way to go. There's no doubt about that.
How about in real life?
I don't know.
Okay.
I feel really clueless about, where the where everything is, and yeah, it's just how I feel. But yeah, if all that's true, I mean, if I wanted to sail, if I was on a globe and I wanted to sail around the world, that's the way I would go. I think. No, I don't think I would. I don't think I would go that way. But that would probably be the quickest way to go because pretty much the winds are with you the whole way. You go down. You go down the Atlantic. Say you're going from France or England. You go down the Atlantic, and the westerlies are pretty much pushing you south. And then I think it just goes the other way when you get in the southern hemisphere. Isn't there like trade winds that blow from east to west, and then you get down into the roaring 40s and stuff, and it's it's blowing from west to east. You're just getting blown across the ocean to South America, and then it's back up into the Atlantic where the winds are still you're pretty much running a beam to all the winds there. I would definitely go that way if I was on a globe.
And we go upwind because upwind's faster. There's a whole lot of physics behind that, but yeah.
I mean, when you see those guys down in the southern hemisphere, they're going, say they go around Cape Hope, and
So
they go around Cape Hope, and they're getting down to those roaring 40s down there. Huge swells behind them and stuff. Those guys go like 20 knots sometimes. They're just like planing on that stuff. Really get pushed fast. It'd be way slower to go the opposite direction. Everything would be working against you to mostly.
It seems to me that your standard of evidence is you have to be able to see it yourself. Is that fair to say?
I don't understand what you're saying.
Have you ever been to Australia?
No, never have.
Does Australia exist?
Yes.
How do you know?
Well, I have a lot of friends who've been there. I know people that lived there and came back. If I really wanted to, if I really doubted it, I could go down to the airport and sit in an airline, Qantas Airlines, and wait for people to come in and ask them if it's real. Just sit there for a couple weeks, and I'm sure everyone coming off those planes would tell me it was real.
Or all the sailors we were talking about, but why are they wrong?
I'm not saying they are. I'm just saying that it's not good enough evidence for me to say that that we're living in this heliocentric universe.
Okay.
Baggage. You know what I mean?
That's fine. and we get geocentric.
That
What about geocentric?
about it.
What about the Earth as a globe and it is at the center of the universe? Does that work better?
I guess that's another possibility.
Does that make the distances that we're agreeing that these sailors go and everything suddenly kind of makes sense, right?
In that case, yeah.
So, how are you feeling about flat Earth?
What do you mean? I think if all of that, if all that we're told about those races and anyone sailing, on that course, if we go along with all the numbers and mileage and all those things, it is a very convincing argument for a sphere the size that they tell us it is. It is. I would say it's the most valid. It's probably the best evidence. Like I said before, I think there might be things that we're not aware of. I'm not aware of. It could make it all not as they say. I'm just trying to be honest.
No, I appreciate that. I enjoyed it. Thank you.
It's so when I started first considering how there could be a flat Earth, was one of the biggest puzzles to me was getting from say California to Hawaii, and the course that I knew you would take, if you were going to go towards Hawaii. Most people go down to Central America and catch the trade winds and go across. That's the way a lot of people cruise that way. And I just couldn't, put that on any kind of flat Earth depiction that I saw. I started thinking about it more and more, and I thought, in some ways, maybe it could be possible. Maybe there's just something I don't know.
Hello.
Hello, how's bacon?
Hey, what's up? How are you doing, Philippe?
Oh, you know, living the dream. It's cold here.
Oh, I don't like cold. I'm very thin, and I suffer easily when it's cold. I feel like I have been annoying to you recently.
To me, no, we're good.
Well, like I think twice last time we'll be in discussion. I was against you or something. Maybe I was stupid. Anything. I don't know.
No, I enjoy being wrong. You know, if I'm wrong and you can show me where, it's all gravy.
Or cool.
I made a claim. Sorry, go ahead.
Kool-Aid still there?
Yeah, what's up?
When I was about 19, I got a job on a tramp freighter, and I went from the east coast of the United States down around the Cape of Good Hope, and then up into India in that area, and then back again the same route pretty much. And I stood the 4 to 8 watch, and that's the one where the second mate is the navigator, and he does most of the navigating. He was using a sextant at that time. That was in the early 70s, and I'd watch him do it and stuff. I had to stand watch on the bridge, and he talked to me a little bit about it. But I don't remember much of what he said. I would ask him questions and stuff, but he'd take his shots, and then he'd go in there like everyone says, and he'd consult his little book about the times and everything, and they plot it all out on charts. And then he had a big map on the flat map on the wall that he'd write the position in, and then he had one down where we were. We were just the crew down below, and there was a big map down there, and he'd come down there and mark where we were each day, so we could watch the progress of the ship.
He'd draw your transit line.
You mean?
Would he draw across the map where you sailed all day? Yep.
Yeah. You transfer from the charts to a big map, big like a whole Earth map.
Yeah, those maps are really cool. But have you ever seen Bacon's little 3D visualization of the stars?
Might have.
Because if you like what they're doing with the sextant, Bacon's got a really cool visualization if he's still here.
I can link that if you want to. If you're talking about the 3D one, you gotta click on 3D view. It's going to show the circles of equal altitude. Is that what you're referring to? Cool.
Yeah. Yeah.
Okay, let me ask you a couple questions because I'm still curious about some things about celestial navigation. Okay, you have some experience with that, right? So
yeah,
maybe a lot of experience with that.
A long time ago, yeah.
Oh, okay. If you'd have to do it today, you'd be okay. Like
I would be good. I can do the math still.
Mhm.
That's the hard part. So
right. So what kind of to use that method in which you use a plotting sheet and then you put the azimuths and the difference between the calculated distance and the observed distance. Is that what you do?
Got-
Hey, Barrow, you hold mic a little bit.
Say that again. I'm sorry.
No, I was just asking what kind of method you do to get a fix.
You're gonna make me actually pull out the book. I don't know. I run it through the formula. I don't even remember it offhand.
You're fading out a little bit.
I run it through the calculator. I was pulling up the calculator here.
Oh, use a calculator.
Yeah. Oh, yeah. I'm lazy.
Okay. No, yeah. I mean, fair enough. It's the 21st century.
Right.
Calculators exist. It's fine. I mean, so does GPS, but then what's the point, right? But yeah, I asked that because I really wanted to understand how want to understand the size reduction tables. Which are they? What they're used for? I have some guess on what they do. I mean, some of my guess I know has to be true based on how the methods work. For example, I know there must be a size reduction table that give you the azimuth of a GP given your assumed position. Is that right?
Yeah. Yeah.
Like, I mean, you have your assumed position in the middle, in the center, and then you have a GP of a star. And then you need the azimuth of that GP from the assumed position, right? And I'm guessing there's a size reduction table for that. Is that right? I'm not sure if your answer, if my connection is really bad, but I don't hear anything. Is anyone else still here?
Yeah, I hear you, Bacon, but I don't hear Kool-Aid anymore.
Damn. Oh, he's back. I think he's having some issues. Anyway, so yeah.
Well, this is stupid.
Who just said that? What's stupid? Is that Riggs? What's up, guys? How we doing? Yo, what's good?
Howdy.
Josh. everybody. Friday. We made it.